Good morning, ladies and gentlemen. Welcome to the third day of EEM 2023. We now begin the first session of talks for today. I now invite the working presidency for the first session to take their seats. Professor Suzana Apostolov, Faculty of Sciences, Novi Sad. Professor Genji Vaštag, Professor Genji Vaštag, also the Faculty of Sciences, Novi Sad. Professor Pero Dugić, Faculty of Technology, Banja Luka. And last but not least, Professor Milorad Tomić, Faculty of Technology, Zvornik.
Good morning, dear guests. We started with first lecture, plenary lecture. Presentation will be presented by Dr. Srećko Stopić.
Just a short introduction. Dr. Stopić graduated from the Department of Non-Ferrous Metallurgy at the Faculty of Technology and Metallurgy, University of Belgrade. In 1991, he worked as a teaching assistant at TMF from 1991 until 1994, when he defended his master's thesis. From 1995 to 1997, he worked as a full-time university assistant teaching theory of metallurgical processes and metallurgy of non-ferrous metals at TMF. In 1997, he defended his PhD thesis on the subject of kinetics of metallurgical reactions. He became an assistant professor at TMF in 1999. In 2001, he was elected director of the Balkan Center for Coordination of Scientific Research and Project Solutions in Metallurgy. He received the Alexander von Humboldt Research Fellowship in 2001. In 2002, he worked on the subject of high-pressure leaching of nickel oxidic ore at IME Process Metallurgy and Metal Recycling, chair and department of the North Rhine-Westphalia Technical University of Aachen, where since the 1st of April 2003, he has worked as a scientific engineer and associate professor for unit operations in non-ferrous metallurgy and metallurgy of rare earth metals. In April 2014, he defended his professional dissertation about nanotechnology and became associate professor at the Technical University in Aachen. In 2018, he became a visiting professor at the Faculty of Technology, Zvornik. Let's welcome Professor Stopić with a warm applause.
Thank you very much, ladies and gentlemen. I hope you have a very nice moment here in Jahorina and very important contacts. I will start with my presentation, but firstly, I would like to thank Professor Vujadinović and Faculty of Technology for excellent organization, also for happy travel. I hope you obtain some award travel or not, I don't know. Also, I would like to thank one professor here, my best friend, and he worked very much for this conference and he supported me. He's our Professor Miomir Pavlović, and I prepared for him because he has problem with health on Scottish medicine. This is one small present for my professor. Sorry. Now I will start. Srećko means lucky man, and always for my presentation involved, first sentence is lucky man is a little nervous. This is one sentence from a movie, from Serbian movie, Maratona, Run, Lap of Honor. And now I will explain you advances in synthesis of new materials is one part of our work in Aachen. Firstly, I will invite my friends to visit Aachen. Aachen is one city in West Germany, and many important topics are Carolus Therme with thermal water. Aachen is the city of chocolate. Aachen has Christmas market, and they have mullet wine as some characteristic, but they didn't know for mullet Šljivovic from Serbia. This is very, very strong. Also, Aachen is a city with underground water, and Aachen has no river because Rhine is in Düsseldorf and Cologne, but we have underground water. And Napoleon and Josefina visited Aachen, Carolus Therme, and this is also invitation to visit Aachen. Aachen is a university city, one of 5 elite universities in Germany. We have about 45,000 students, 1 professor, 100 students. This is total different to Serbia. Or also we have 152 study courses and also 32% female students. Most important is that Technical University in Aachen is #1 in Germany for funding for mechanical engineering, for metallurgy. Regarding our university, short introduction, we have 9 faculty, and I am at faculty 5, Georesources and Materials Engineering. Also, we have typical metallurgical departments, metal forming, physical metallurgy and metal physics, ceramics, glass, industrial furnaces, and heat engineering. But my work at the Institute for Process Metallurgy and Metal Recycling. Regarding subject, recycling metallurgy is #1 because we have industrial cooperation in Germany. We have many possibility for funding in Germany. This is electric arc furnace metallurgy. Also, we have hydrometallurgy. I am responsible in our institute for hydrometallurgy and nanotechnology. Process technology of metals has a different group: vacuum, production of complex alloys, pyrometallurgical refining. Also, we have a group for simulation, but we are an experimental institute. We have to perform experiments in order to obtain money. A special area: aqueous and molten salt electrolysis, powder synthesis, and also synthesis of metallic, oxidate, and composite nanopowder. This is one part of our equipment. I will explain it in detail in this presentation. This is from company Prisma from Serbia, ultrasonic atomizer for production of aerosol of metallic salts for synthesis of different metals. Regarding unit operation, this is my course at master program in Germany. I will shortly explain different operation. Firstly is dissolution, digestion in autoclave or leaching equipment. Filtration is one separation process. Precipitation is for cleaning of solution. Solvent extraction is the separation liquid-liquid. Crystallization is formation of metallic salts, and traditional is metal winning during electrolysis. This is my course in Germany, but this time we will forget it. I have chosen only synthesis of powders. This is instead this electrolysis. We will give some new information about advanced synthesis of materials. If you need more information, you can see my two books. First book is Advances in the Understanding of Unit Operation on Ferrous XRT Metallurgy. And I am a member of editorial boards of Metals, MDPA in Switzerland. And also, if you will submit some publication, you have time until 31 July. And this presentation is connected with my first book, Advances in Synthesis of Metallic, Oxidic, and Composite Powders. Regarding my activity, I didn't say it. I am an expert of diaspora. It means German Ministry of Migration included me for diaspora engagement. It means I can choose one organization in Serbia and spend 3 weeks or more to transfer this knowledge. In this month, I'm guest of Faculty of Mining and Geology in Belgrade, and each week I have one presentation. In this book, I prepared a story about 15 successful people, academics. They are in San Diego, Toronto, and of course, Europe and other countries that you know that these people are successful as scientists, also that they have hobbies. And for this book, I obtained one award in city Užice in previous year. Regarding this lecture today, I will present you synthesis of nanosized particle application, and we will go step by step. Firstly, about method, horizontal ultrasonic spray pyrolysis reactor, vertical, scale up, and this is only one sketch, ultrasonic atomizer, one furnace with 4 different heating zones, and this is regarding our last experiment, and we have possibility to make regulation for each step, for each zone. We have some automatization of process. Regarding nanotechnology, maybe you have many information. Medical application, for example, nanogold is used against cancer. Nanogold particles can destroy cancer in our body, also in textile, our t-shirt with silver, also in food industry. Environmental science, for example, iron is used for purification of solution, and also for fuel cell, we use different metallic oxidic particles, especially in lithium-ion battery. Regarding application, we have different application in electrical engineering. Maybe Professor Petrovic can find this application, and conductors, semiconductors, insulators. Yesterday, we obtained information about silica as insulator. We made also synthesis of nanosilica, and especially important for me are magnetic materials: neodymium iron boron, iron cobalt. And today I will explain synthesis of these materials using ultrasonic spray pyrolysis. We have two possibilities to make synthesis of these particles. If we start with molecule, atom, we have bottom-up method. If we start from submicron particles with grinding, we have top-down method, and we can choose regarding the cost what is the best solution for the synthesis. Regarding my work at the Institute, regarding our equipment, our project, we have used ultrasonic spray pyrolysis method, chemical reduction in aqueous phase using sodium citrate, fine grinding, and this is one list of my project. This nice lady from Novi Sad, Jelena Bogovic, was my PhD student, now Doctor of Science, and in Bonn. This is only example that I can invite also PhD student to work in our institute. And my aim here is not to impress you with this data, but also to find some cooperation, some young people to work at our project. And Jelena is excellent example. She was the best. She was the best. And regarding our project, for example, synthesis of metallic oxidic composite particles, this is one project. We worked for industrial companies. We work for a German project, German Association of Research. This is a basic project, synthesis of gold, silver, zinc oxide, silicium carbide, titanium oxide. Also, we combine recycling process. For example, hard metal, tungsten, carbide, cobalt. We dissolved this material and obtained cobalt nano-sized particle with our colleague in Turkey. Also, synthesis of core shell particles. It was PhD subject of Jelena. Gold of titanium oxide, silver of titanium oxide. Also, ruthenium oxide, titanium oxide for company Covestro, and Victoria worked with material, Bayer Material Science, now Covestro. This is applied research. Also, synthesis of lithium iron phosphate. This is synthesis of cathode materials. And we worked also synthesis of magnetic materials and different topics. And why is it important to work with nano-sized particles? If you compare price of gold, it was 2050, now it's about 50 euro. But if you have smaller particles, the price is higher. It means for 1 gram of nano gold, you have to pay about 2,580 euro. And this is problem because it's not easy to synthesize this powder. Now about ultrasonic spray pyrolysis. This is a typical product of ultrasonic spray pyrolysis, ideal spherical particles of silver. Characteristic through the thermal decomposition of solution, and after that collection of this particle, and we have opportunity to use oxygen for oxidation, hydrogen for reduction, or thermal composition, and produce one spectrum of these materials. Also, we we can combine different water solution in order to produce very fine powder. But these spherical particles are very important for different application. What is the problem? The problem is you cannot produce kilo per hour, but you can produce, for example, 8 liters per hour. You can produce about 4 grams per hour, very fine powders. Regarding some calculation, you can predict the particle size. You can predict the aerosol size if you know frequency of ultrasound. For example, in leaching reactor is 40 kilohertz, but in ultrasonic spray, ultrasonic atomizer is 1.7 megahertz. This is important, and we can calculate using information about surface tension and density of solution what is aerosol size. If we use aerosol size, concentration of solution and density of powder, we can calculate diameter. What is the expected particle size? We know if we have higher frequency, droplet size is smaller. If we have higher concentration, in this case, we have submicron particles, higher particle size. It means for each water solution, I can calculate what is theoretical value of our powder. If you need more information, this is my book, 2015, Synthesis of Metallic Nano-Sized Particles by Ultrasonic Spray Pyrolysis. This is my second PhD at the German university, because if you have to work with student and university, we have to finish some habilitation. And this is something, and I finish it. And after that, I had to give one talk, 45 minutes at German university in the presence of rector and other group. It means this is some obligation. I survive it. And this is Prisma, ultrasonic generator, Prisma Kragujevac. Prisma Kragujevac is a leading company for medical equipment. But before 10 years, I visited this company. I told, you have atomizer for inhalation for people. Can you prepare or build new generator for metallic salts, for chloride, nitrate, sulfate, and change your construction? They made it successfully. At the beginning, price was about 300 euro for this inhalation generator. Now it's 7,700 euro, and these generators are in Europe distributed. And this company has also one shop, one part in Düsseldorf. Regarding process, we have water solution. I hope Dr. Zaric can remember on the work. And after starting of this work, we can, during work in ultrasonic field, obtain some small geyser, because we have many waves here in these ultrasonic fields, and these droplets, this aerosol, will be separated and transported with carrier gas to the furnace. In the furnace, oxidation or reduction or thermal decomposition. And after that, in these small bubblers, we can collect this particle. This is in laboratory. We have different process: solvent evaporation, firstly of droplet, decomposition of droplet, and formation of porous or hollow particles, densification, and formation of solid particles. This is one mechanism for this ultrasonic spray pyrolysis and hydrogen reduction. For some information in world or some competition, I have chosen this equipment for ultrasonic spray pyrolysis. This is ultrasonic generator. We have one high quality quartz tube for the experiment until 1000 degrees. But if we will make synthesis at 1300, we can use ceramic tube. After transformation in furnace, we can collect particles now in electrostatic filter. Electrostatic filter is something the best in this moment for the collection of particles. The problem for collection is how to improve efficiency, because if you collect particles in a bottle with water, efficiency is 25%, but we need more efficiency in order to collect these particles. Now I will show our equipment. This is our equipment, Carbolite furnace in Germany, ultrasonic atomizer from Prisma, Kragujevac, gas station, this argon for transport of gas, and it was one system for collection of powder. This is one system with automatization. This is my first picture in Kragujevac, and this is the newest equipment in Kragujevac. And for continuous transport of solution with one pump, that we have continuous process for synthesis of powder. It means it's not important that here is 500 milliliter or 1 liter, because we have continuous transport of solution and continuous transformation. This is only for you. This is the newest product by Prisma Kragujevac. It will be present at market in this month, because I participated in development of this generator, and this electrostatic filter has about 80% of collection of efficiency. This is something the best at this moment in this field. Only for you, some details regarding of collection of particles, collection and synthesis, nanosynthesis of magnetic particles. This is one rotated electrode, and you can see some product in comparison to other electrostatic filter, about 28 kilovolt. This is only energy about 7 kilovolt. Now about vertical equipment, because we started our work in horizontal equipment. My director, Professor Friedrich, told me, Srećko, we have to improve it. We have to prevent this loss of solution during some contacts. And we found firstly this equipment in Japan. It was very interesting. And we decided to build one equipment in our institute. And we use it. It's one sketch for synthesis of titanium oxide. Titanium is very important element, because in red matte we have about 6% of titanium, and we will develop one project regarding formation of titanium or titanium oxide. And you can see ultrasonic atomizer reaction tube and electrostatic precipitator. And now we have developed it, and you can see I was beautiful and young then. Now I am just beautiful. And this is electrostatic filter, and you can see very nice red color. This is copper. We developed also one electrostatic precipitator, but we didn't have this efficiency of 80%. This is something what we developed. This colleague, technician Dieter Leimbach, worked with me, and we developed many equipment. But in Germany, if you finish one job, you have to start Victoria with new job. And in this case, Professor Friedrich told me, Srećko, scale up. One line is not enough. And we make project with 5 line, building of scale up. And in also electrostatic precipitator, and also to produce more than 100 gram with 4 temperature zone and about 6 meter was high, this equipment. We have built it, and this is my team: Jelena Bogović, Švinga Alexander, both doctor of science, and Prisma products, 5 ultrasonic generator and 1 system for continuous transport of solution. This is system for collection of powder. And first results are synthesis of nanosilver at 800 degrees. You can see our friends, Sava Maksimović, Miroslav Ravlić, and Konstruktor from Poland. This is after our experiment. Now, I will give you different example of our synthesis. For example, synthesis of nano size silver from silver nitrate. We had this reduction. We have 2 different zone: evaporation zone, reaction zone, and collection of powder into water bottle. This is our equipment, and this is one quartz tube, and you can see here this powder as product. And after synthesis of this powder, we can take this suspension, scanning electron microscopy, and EGX for elemental analysis. Also, we made synthesis of magnetic particles. Mixture of nickel chloride and iron chloride in solution. After reduction, we obtain nickel iron powder, and we publish it in Journal of Alloys and Compounds. And also we made it with cobalt chloride, mixture of cobalt chloride, iron chloride, and you can see these round particles. And also different XRD analysis, also we publish it without problem. Why is it important to publish these results? Because always someone read this paper, and one company invited me and told me, Srećko, can you develop these powders with specific characteristic for our company? Of course, we can do it, only you have to pay. And this is our strategy in Germany, very simple. And you can see some results also if we use iron nitrate. This is one possibility, nitrate, chloride. And also in this case, this is not our work, but you can see if you did not choose parameter. If you cannot control this synthesis, you cannot obtain ideal spherical particles. They are important for synthesis. My favorite job is to make bilateral project with Serbia. This is my first bilateral project with the University in Kragujevac, and optimization of our ultrasonic spray pyrolysis. This is numerical simulation of silver nanoparticle formation. We have chosen most important parameter: temperature, concentration of solution, frequency. And after work with neural networking, we made optimization. This artificial neural net learned of this process, and we obtained one area, one equation, and we can choose always some parameter if we know some what is the constant, and it was optimization of our process. Now, something about synthesis of ruthenium oxide, titanium oxide. It was my project for German Association of Research, because ruthenium oxide is active oxide for catalytic application, and the process is similar other ultrasonic spray pyrolysis. We have different precursor: ruthenium chloride, orthotitanate. After atomization, evaporation, and precipitation, we obtain different particles: titanium oxide, ruthenium oxide, but it was not good. Our aim was to obtain ideally spherical particles and core shell particles. That this core and shell are separated. In this case, we built new equipment with new generator. One generator produced titanium oxide, and after that, we mixed ruthenium chloride, titanium oxide. In the second furnace, we obtained this titanium oxide, ruthenium oxide, because it was only one way to obtain these particles, ideally core shell particles, ruthenium oxide, titanium oxide, and we publish it in Material Research Bulletin. After that, company Bayer Material Science, now Covestro, from Leverkusen, invited me to make something practical. They have a node. They need our ruthenium oxide particles. They need it for oxidation hydrochloric acid, for production of chlorine. And our aim was to construct a new system for deposition of ruthenium oxide on a node in ultrasonic field. And you can see our new electrostatic filter with possibility to make heating at 600 degrees in order to deposition of ruthenium oxide at titanium anode. It was our aim and aim of this company. After that, we analyzed this coated anode, and you can see these spherical particles are here at this titanium anode, and company Covestro use it in process, and they compared it with results with other titanium anode from this company. Now, we like very much gold, and our aim was also synthesis of nano gold, but synthesis of nano gold is not possible if this dissolution of this scrape is not possible. And also for electronic scrape, we use this mixture of hydrochloric acid, nitric acid, produced our solution, separate some impurities, and use it for synthesis of nanogold. For this job, we had cooperation with Faculty of Maribor, Professor Rebecca Rudolph, and also Zlatarna Celje gave us some Jeverli scrap in order to produce nanogold, but nanogold for medical application. It means is gold biocompatible with our body? And the Institute in Belgrade for medical investigation used our particle for this analysis, and we confirmed that gold is biocompatible, and we published it in the biomaterials application. Very interesting. Gold is not spherical, similar silver. Gold is cylindrical, and also we have some round particles, but this is important for different application because the form of particles is important for application. Now, my last project, this is a German-Turkey cooperation, recycling of neodymium iron boron magnet. Neodymium iron boron magnets are used for this wind central and for motors and different application. And our job was to analyze firstly this powder after demagnetization, after grinding, and use it in one process. For example, acid baking. Acid baking is mixing with acid about 150 degrees in order to make separation of iron oxide. And after calcination, because we need one solution, pure solution for synthesis of our particles. The problem is if we have rare earth elements, these lanthanoids, it's not possible to obtain rare earth metals during this method. We obtained only oxide, but for synthesis of rare earth elements, we have other project with our colleague, Institute for Chemistry, Technology and Metallurgy in Belgrade, molten salt electrolysis for synthesis of rare earth element. Now, again, synthesis with the colleague from Slovenia, high entropy alloys, 5 elements in same semi-molar ratio, silver, platinum, palladium, copper, nickel. Colleague Lidija Simić made synthesis, and after that we have some scribe, silver, palladium, platinum, copper, nickel, and after hydrometallurgical treatment we prepare a precursor and ultrasonic spray pyrolysis with hydrogen reduction in order to produce again this alloy, but in submicron or nanosize form. This is our publication in metals. After that, in Slovenia, additional work was freezing of this structure, and we prepared this silver, platinum, palladium, copper, nickel, and you can find also as paper bilateral cooperation with Slovenia, synthesis of nickel yttrium oxide for catalytic application was finished in last year. It means we have many possibilities to produce this nanosize, particles, we have different application. And as conclusion, ultrasonic spray pyrolysis method with hydrogen reduction enables production of metallic, oxidic, and composite powders. Also, depending on application, we can prepare different particles. Also, we can use waste solution. After purification, we can produce these powders. And I'm very happy that I presented this work here. I'm very happy that I obtained new idea here in Jahorina, especially yesterday evening, music and also as conclusion, for me, benefit is I obtained new chance for PhD position at Faculty of Science, Charles University in Prague. Maria is open field place for me. Okay, and thank you very much.
Dr. Stopic, thank you for this interesting presentation. Now I open discussion about this object. Is there any questions?
That's for my tasting partner.
Always.
Always. I have one question. If you say the shape of nanoparticles is very important, in your opinion, what is the best way to control the shape?
This is in case ruthenium oxide, because ruthenium oxide is the active for a catalyst. How to control it? I didn't say, but residence time is most important. Residence time, it means we have different chemical reaction in a tubular reactor, and if we have not enough time, our transformation is not complete. This is very important, and because we worked one-step synthesis, and one-step synthesis, it was not enough time for this synthesis, and this synthesis with two reactor and two ultrasonic spray atomizer was one solution.
Thank you very much.
Another question, okay. Professor Pavlovich.
What do you think? No. What do you think about the quality of red moods in Birac?
Quality of red mud is with titanium 6%. This is important for our project proposal. In this moment, I have to inform you until 20 April. We have time to submit one project, Faculty of Technology, Zvornik, Alumina, and our partner in Paris, in Athens, Germany, Aachen. I will take 1 kilo of red mud this time to bring to Aachen, and the quality of this red mud is enough good to start our experiments, because this is a big problem, and not only ultrasonic spray pyrolysis. I have to give new information. It was not topic of my work. Carbonation of red mud. In May 2022, I visited Alumina and Faculty of Technology with people from Stockholm, Helsinki, Amsterdam. They have shown interest for this red mud for carbonation process. Carbonation process for red mud is important to absorb CO2, and this product can be used in cement industry. This is the second important application. At this moment, people will prepare one continuous line for carbonation, but they were impressed with work in alumina regarding autoclave line. And I'm sure that this red mud will be treated with some methods, and we will compare it also with some red mud from Greece, and because alumina factory in Greece also have this red mud. I don't know, maybe Obrenović, director, will give us information about scandium in red mud, about rare earth elements, because we had project with Greek colleague and people from Belgium. Recovery of all elements, valuable elements from red mud, titanium, scandium, iron, aluminum. It means maybe to make one analysis, because we had 15 PhD students out of Germany. They worked only treatment of red mud, connecting with different elements, and also regarding safety, regarding some hazardous materials. And I hope now is chance. And do not forget, Maria was here, as Greece, this waste management, and maybe that this conference is a high benefit for Zvornik and Faculty of Technology, Alumina, that we can work together, and also this colleague here can help regarding solving of problem treatment of red mud. If this project will be funded, while we will drink together.
Dr. Stopić, thank you very much.
Now I have permission to travel to Belgrade.
Okay,
Thank you very much.
thank you. Now we continue with invited lecturers, and presenter will be Dr. Matej Haš, but previously we would like to hear something short in introduction about Dr. Haš.
Dr. Matej Haš is a researcher in heterogeneous catalysis at the National Institute of Chemistry, Slovenia, and assistant professor at the University of Nova Gorica. He earned his PhD in physical chemistry at the University of Ljubljana, Slovenia in 2015, and he did his postdoc in chemical physics at Chalmers University of Technology in Gothenburg, Sweden, 2018. He works in the field of chemical modeling and simulations of heterogeneous and homogeneous catalytic reactions. His area of expertise is quantum computations, kinetic modeling, and Monte Carlo simulations. Recently, he has been focusing on describing photocatalytic systems where electronic excitations play an important role. At the University of Nova Gorica, he teaches quantum modeling and multi-scale modeling. He leads a theoretical catalysis group at the Department of Catalysis and Chemical Reaction Engineering at the National Institute of Chemistry. The group deals primarily with the simulating catalytic chemical processes at all scales, from quantum phenomena to the reactor level description. The group is included in more than a dozen European Horizon projects. Therein, they have studied CO2, hydrogenation to methanol, NH3 production, ethylene, epoxidation, and other important reactions. Collaborating heavily with experimentalists, they use simulations to both support and understand the experiment, as well as to predict better catalytic formulations at reactor conditions. Let's give Dr. Hush a warm applause.
Thank you very much for inviting me here. If I had known that you would read all that, what I wrote, I would have written a shorter introduction. Thanks for having me here. I really enjoy it here, the venue, people, the food. It's also the first talk I'm giving in flip-flops, and I also hope it will be the last one. So this is the slide I always open with, although I'm sure that everybody knows where Slovenia is. So our institute is located in the capital, in Ljubljana, about a 6-hour drive from here. So this is a couple of photos from the capital, this famous triple bridge. This is our institute, and a couple of pieces of information. So there are approximately 300 people employed there, working in different fields from biochemistry to chemical engineering, catalysis, material science, and so on. And we're always open to new prospective PhD students or postdocs or anybody who wishes to work there, but more on that later. This talk will consist of 2 parts. So firstly, I'll talk a little bit about what multi-scale modeling is, and in the second part, I'll walk you through a couple of examples where it was used and how it helped us. So multi-scale modeling is basically, it has become feasible in the recent years due to the advances in the computational power. Basically, it means that we're trying to model the system at different length and time scales. And because we need different methods to be able to do that, we also need methods to couple these different methods. And so one typical example of multi-scale modeling is that you, for instance, couple at least 2 of the scales or methods that I list here. So basically you have the quantum level where you deal with electronic structure and the energetics. Then you have the molecular dynamics level where you deal with dynamic properties of the system. And then you're going to go up to the kinetic Monte Carlo or the kinetic system where you basically compute the kinetics of the reaction of your system that you're studying. And then you can also model the system at the microscopic level. So if you want to, get a good deal of information about the reactor itself, the residence times, the velocity fields, and so on. So basically, in quantum chemistry, I won't go into details because we are running a little bit short on time. We have half an hour. So basically, you're trying to solve the Schrödinger equation, which is, let's say, difficult. You can't do it precisely for systems larger than a hydrogen atom. So what you usually resort to is doing some DFT. This is done because it has the best cost to performance ratio, so you can get the most out of it for the least amount of the computational time that you invest. Basically, with DFT, you're trying to get the electronic density of the system and get some properties of the system based on that electronic density. To most people, it looks like a black box, but it's not really a black box. It just means that if you don't know what you're doing, you're going to get rubbish out of it, and you won't even know that you're getting rubbish out of it. So this is the main problem with doing DFT. So, in general, you can do it in periodic systems or atomic systems, which are isolated systems. I mostly deal with periodic structures because I work in heterogeneous catalysis. So yeah, what can DFT give you is it can provide information like, so basically you need to have some experimental data, at least to start with, that you can get from XRD, XPS, TEM, or so on. And then you can do DFT on that, and you can get information about the energies of different structures or different surfaces of your catalyst on the termination of your surface. So if you have, for instance, an oxide on the top or sulfide or whatever, then you can also model the effect of temperature and pressure and gaseous environment and so on. Although DFT works at 0 Kelvin, 0 bar, you can use that. You can include that in post-processing. with statistical mechanics, and you can build all kinds of nice phase diagrams and so on. Then what people mostly do is they use DFT to optimize geometries of their systems. They can study absorption interactions and so on. And sometimes people ask me, okay, if DFT lives at 0 Kelvin and 0 bar, how do we get anything useful for non-zero conditions? And fortunately, the geometry is rather independent of temperature and pressure. So what I mean by that is that the lowest lying energy state is always the same one. But if you have a finite temperature, what happens is that you have a broader ensemble of available structures because they are spread around this local minimum. And then you have another problem, and this is the timescale problem. Because people who don't do theory, they always think you're just going to input what you have in the computer, press play, and you will get a whole description of the system, which is, of course, not true. This does not happen. The transition state theory is a theory that allows you to say something about the kinetic parameters of your system if you have mapped the energy surface. So unfortunately, what that means is that you need to have some prior knowledge of the system you're trying to simulate. And this is usually mutually exclusive. So in that case, you either resort to some chemical intuition, or you just do some brute forcing. If your system is small enough, then you can just probe all possible reaction steps. But basically, you need to find, if you are interested in the mechanism, you need to find transition states, which is difficult, but it can be done. For instance, we were working on a very, at least on paper, simple reaction. We're trying to get from CO2 to methanol, which is one of the CCU, so carbon capture utilization problems. And you would think that this is a simple reaction, but this was the reaction pathway that we came up with. And I'm sure it's not exclusive. There must be some other steps that we might have omitted. And then in bold, we show what was later computed to be the most important or the predominant pathway on one particular catalyst. So, you use TST, and then you end up with your activation barriers and reaction energies and so on. And that you have to do for every reaction step. And you also have to take into account in that step is, for instance, an activated absorption, non-activated absorption, or so on. Surface reaction or whatever you have. This was briefly the quantum level. Then you can go up to the higher level, the kinetic Monte Carlo level, kinetic level, where you then, now having all the energetics and the reaction parameters, then you actually model the system. And to do that, you have to decide on the temperature and pressure you want to model that. You need to know something about your catalyst surface. You need to have the DFT data. And when you run the kinetic simulation, what you get out of it is a temporal evolution of the system. So basically, you can get the lattice coverage, how many and which species you have on your catalyst. You can get the number of the reaction steps that occurred. You can get the products. You get the time, so the TOFs, turnover frequencies, and so on. And this is, for instance, animation, what you get out of the kinetic Monte Carlo model, which shows how this reaction going from CO2 to methanol, how it looks like on one particular catalyst. Again, the kinetic Monte Carlo, so the Monte Carlo part comes from the fact that this is a stochastic simulation, which means that you are choosing a step at random, because it turns out this is way easier to do and implement than solving analytic equations. And so basically you have to list all the allowed reaction steps, and then you just take one at random. You advance the time scale for the appropriate amount of time based on the frequency of that step, and you rinse and repeat. And then if you do it right, and if you run it for a sufficient amount of time, you get sort of reasonable results which you can trust most of the time. And then at the higher level, which is done usually with CFD, computational fluid dynamics, which is what my colleagues do, You can use all of that information that you've gathered in the lower steps, and then you construct a model of your actual reactor, and you compute, for instance, the pressure drop, the fluid flow, and so on. You can include the heat and mass transfer limitations, and that will tell you how your reaction will run in a particular reactor that you have. Because it turns out that has a very large effect on the overall productivity. And now, very recently, people in our group have started doing simulations on membrane reactors. So this was just done a couple of days ago. And they have shown, so basically they've tested different implementations of these reactors, and they checked how they influence the reaction rate. And this, I think, can you play on that? Yeah, so this is an example. So this is how you do packing. So, you know, if you have a reactor that packed bed reactor, then you can do different. You can do the packing many times, and you get slightly different packings, and then you run the simulations in multiple instances. And then this is what you get out. So this is a conversion of CO2 along the reaction lane. And then you can, you know, CFD is also useful to plot figures for project proposals, because you can get out all kinds of very nice figures. But what I want to talk in the second part of this talk. So this was, you know, very briefly which methods we use. There are other methods as well, but the ones that we focus on, which we use to solve different problems. And now I'm going to walk you through 4 examples where we use different levels of multi-scale modeling and different complexities, and which questions we were trying to answer with this modeling. So this was the first problem that we had. That was back in 2016, and it's not really a multi-scale. It's still more of a single scale. Basically, methyl nitrocatahols are secondary organic aerosol tracers. So these guys just, you know, pop up in the atmosphere, and they come about when you have nitrate, so NO2 plus ions, or and free metal catahols, which are produced when you have wood burning and so on. And then they nitrate these 3 metal catahols, and you can, in principle, you can form these 3 products. So you can have the nitro group on site 4, 5, or 6. So you can get this 4. And we didn't know which ones formed. And the analytics we had available at the time was not able to distinguish between these 3 isomers. So what we did is we did some DFT. In this case, DFT alone was enough. And we computed the reaction pathway, you know, for nitrating different 3 metal catahols. And what we found out is that DFT predicted that the 4 and 5 isomers would form, whereas the isomer on the side 6 wouldn't. How we saw this? Because the reaction barrier, so the activation barrier for the number 6 was higher than for the number 4 and 5. And later on, when we did the experiments with more advanced analytic equipment, this was found to be true. So only 4 and 5 isomers actually form. So in this case, DFT predicted successfully what happens in the real world. And maybe a quick side note here, this is what DFT is most useful for. So you wouldn't necessarily trust it to get the numbers right. You know, they can be shifted, but you would trust it to get the trends right. So in that case, you know, it doesn't really matter if that barrier is 19 or 29. What matters is that the other one is higher. Then in the second example, we were investigating CO2 activation on Syria. So again, this was a huge experimental undertaking where the part of our group, or the theory group, was rather small. Basically, we were asked one simple question, namely the experimentalists saw 3 different signals. The signal had 3 peaks for CO2 absorption. And they asked us, can you explain that? Can you, find some reasoning why we see 3 peaks? I mean, obviously that means that CO2 can bind in 3 different ways, but can we give a little bit more information on that? This is what the experimentalists would draw. They would say, it can bind as a monodentate, bidentate, or polydentate species. And these are the nice figures they would draw, but obviously we wanted to model it. And what we did is we built a structure of Syria. This is known. This has been known for quite some time. And then we, tried different configurations of CO2. We tried different geometries, optimize the structures. And what we found out is that, yes, you can actually have different modes of absorption of CO2 on that Syria surface. And they have different energetics, so the strength of this absorption varies. And this was, roughly in line with what the experimentalists measured. Now, of course, we went a little bit further, and then we tested different surfaces, because you cannot be sure that you have a 1-1-1 surface all the time. You can also have a 1-0-0 surface, and then you have also different defects, and you can have oxygen vacancies and so on. This was published last year, but basically theory again was in quite a good agreement with the experiment. This was the role of theory in this example. The next example, which still touches upon CO2 reduction, is the catalyst structure. So we have known, everybody knows that usually you don't have a catalyst that is just copper or any other metal. You would have multi-phase catalysts, and they outperform this simple catalyst all the time. And the question is, can we describe this with a model? Can we show why this happens? And the good thing about doing simulations is that you can simulate things that don't really exist in a way that you can decouple effects from each other. You can focus on just one effect and neglect the others. I'll show you in a minute what I mean. So what we did is, this is the reaction mechanism that you have for this simple reaction, reverse photogaseous reaction. So you want to go from CO2 to CO, and all the other reactions like hydrogen spillover and so on, just to close the mass balance. And then what we did is we constructed or built a model of 3 different catalysts. So this is a copper 1-1-1 surface. This is a strontium titanate surface. And this is the interface. So where you put your copper on that strontium titanate. And what we did next was we used DFT to compute the reaction mechanism on all 3 catalysts. So on the interface, on copper, and on strontium titanate. And we did this boring job of computing all the intermediates, all the activation barriers, and so on, which was done by a PhD student. And then the important part, or why this is the multi-scale modeling example, is that we use these parameters from the DFT to run a kinetic simulation. And the kinetic simulation was run on different lattices. So this is what I mean when I say that we can model things that don't necessarily exist, or that you can force your system to be in whatever state you want it to be. This is just the support. So this is strontium titanate. This is just copper. And then what you also have here in between is the interface region. And then we ran this reaction with varying sizes of that copper island in the middle. And this is what you get. So basically, it is quite expected. So the smaller your copper island is, if you normalize that by the amount of sites, you get a faster reaction, which sort of makes sense because you see that the reaction, also a priori, that reaction happens on copper. But what we then also could do is we can also say, let's run the reaction only on the interface. Now, in real life, you cannot have just the interface. You would have copper and strontium titanate. But in a simulation, you can also say, no, I just want to have the interface. And we ran the reaction at the interface. And then we said, okay, let's run the reaction without the interface. Because in a simulation, you can say, I just have copper and just have the strontium titanate with no interface. And what we found out is that you need to have all three for the reaction to be the fastest. So this is what we showed. This is how we showed that there must be some synergetic effect between the three. Because we know from, well, we know people talk about it, that the interface is always the most active phase, that the reaction proceeds fastest at the interface. But what we've shown is that although this is true, if you look at these three scenarios individually, if you include all three, then the reaction is even faster than just having the interface. So, these are the kinds of things that you can only do in a model, or you might be able to do it with some very convoluted experiments, but it's way easier to do it modeling wise. And then the fourth example, which was the largest one of all, is we were looking at ethylene epoxide. So this is one fairly important industrial reaction where you start with ethylene and you want to produce ethylene epoxide, this guy here. And this, people have scanned the periodic system back and forth, and they have seen that silver works best. Now, this silver is, of course, doped with alkali and with chlorine and so on, but you can't do it without silver. And what we asked is, can we do it better? Now, to spoil it, obviously not, but can we still learn something from modeling this reaction on all kinds of different metals? So what we did is we first postulated the reaction mechanism. And to be able to say something about selectivity, you need to include the reaction steps that also lead away from the product. So, you start with ethylene, you want to go to epoxide, but you also need to include these steps, which will give you CO2, which is something you don't want to have. And then we said about screening the whole periodic table, so at least all the metals. And you can't do DFT on all the metals, especially if you think about it, you would also need to test different facets. You would also need to test different defects and so on. So, it becomes unwieldy. You can't do it for all of them. But you can be clever and do it just for some of them and then extrapolate the data to the other metals. So what we did is we tested this reaction on 10 different metals. By tested, I mean we did the whole DFT. So this was, again, a very tedious job. And you get all kinds of numbers. So you get the reaction barriers, you get the reaction energies for these reaction steps on these 10 metals that we've chosen. And then what we did is we try to correlate this data with some simple descriptors that we can easily obtain for every metal in the periodic system. And the most straightforward choice of the descriptors is just to look at absorption energies for copper and oxygen, for carbon and oxygen. This you can do very easily. This is a 5-minute preparation, and then you just wait for 2 hours for the supercomputer to chew on it, and you get it. So we computed these descriptors for the whole periodic system. And then we try to see if they correlate with the full DFT values for these 10 metals that the whole mechanism was computed on. And what we found is that, yes, they do. So again, this is not, it has been seen before on other reactions that this can be done. This is a so-called BPE correlation, but it was also nice to see that it fits so well also for ethylene epoxidation. But most importantly, then we did the kinetic modeling based on these values, because suddenly you had the descriptors which allowed you to predict the kinetics for every metal in the periodic system. And this is what you get. So this is a plot of the turnover frequency as a function of these two parameters. And here I also show the metals where they lie. And you see that silver is well, close to the top of this volcano, but not on the very top. Just to step one step back, no experimental input has been used so far, and yet what we get matches reality quite well, because we know that silver is the best catalyst for oxidation. We also have the alkali here next to silver, and we know that they are useful dopants. And there are some other metals here also in the vicinity, which we decided to test. So we chose all of these metals that are in the vicinity of silver. We omitted mercury for obvious reasons. We redid the DFT on these single atom alloys using these metals. And what we get here is, so what you're interested in is this two reactions. So you want to produce epoxide instead of acetaldehyde, which goes to CO2. So basically, to keep it short, the lower this bar is, the better. For silver, it's almost zero. And then if you look at the first bimetallic alloys and then trimetallic alloys, you see that they should work better. At least this is what DFT tells you. The best ones should be silver with copper and cadmium, or lead, or thallium, or zinc. And then I had a postdoc synthesize these catalysts. Why synthesize? Because if you buy them, you get all kinds of impurities in them. So you can't be really sure what you're buying. I mean, they say it's silver and they say it's silver with copper, but what else is there? Which promoter they use? It's difficult to tell. So we synthesize all of this in-house. These are the chem images that you get. And we tested them in a reactor. So this is silver, and then if you compare it to other bimetallics and trimetallics, looking at the red bar again, so the epoxide selectivity, you see that it matches what we predicted from DFT and kinetic modeling. So we only, not everywhere, so for silver, copper, zinc, it's roughly the same, but if you use cadmium or lead or thallium, they perform best, and they are quite an improvement compared to silver. Now, of course, they are all very, very toxic. So, that's why they are not used in industry, I guess. So yeah, these two perform the best. So these were the 4 examples where we used different kinds of modeling to either answer some questions or to manufacture some problems that we then solve. Now a short commercial break. So what are we doing at the moment? So the focus of research also in the community and in our group has focused to photocatalysis and electrocatalysis. So this is being investigated more and more. We are also playing with inductive heating, which is also very nice. You take nanoparticles made of iron, you coat them with some catalytically active metal, and then you use this to carry out your reactions, because in that case you can heat the catalyst with inductive heating. So you put it in a coil like this. In that case you have less of losses, energetic losses. We also work on biomass conversion, methane valorization, and so on. So yeah, the take-home message of this talk is multi-scale modeling consists of coupling at least 2 different methods on different scales. So individual methods are pretty well developed. Although for photocatalysis, people are still developing methods, but they are in principle good enough. Their coupling is a problem. So how to use input from one method to the output from one method as an input on the other, because you have to do it on different scales. And it's very important to benchmark that with experiments. In that case, we are very fortunate because our department, 80% of people are doing experiments, and maybe there's 5 of us doing theory. So we are swamped with experimental data that they need us to explain. And yes, garbage in, garbage out. So if you have bad inputs, you will get bad outputs and you won't even know it. until the reviewers tell you that in a very blunt way. So yeah, this brings us to the end of this talk. So I would like to acknowledge our institution, so Chemijski Institute in Ljubljana, Slovenia, Department of Catalysis and Reaction Engineering. As I said, we have a couple of open PhD positions for this fall. So started in October. They are for either experimentalists or theoreticians. If they are theoreticians, they should contact me. Experimentalists, they can talk to my colleague Miha, who runs the experimental part of it. We also have postdoc positions on some European projects. So the same applies. You can either contact me or Miha, depending on what you want to do, or you can tell that to your students. And yeah, I would like to close off by thanking first the founders, the agency and the European Commission, and then also you for having the time and to stick and to come in the morning after yesterday's party. So thank you all.
Dr. Hush, thank you very much for this interesting and clear presentation. There are many interesting and useful results. And now I open discussion. Is there any questions for Dr. Hush? Okay, please.
Thank you very much, Dr. Krush, for your wonderful presentation. We really liked it, and we keep saying to our colleagues that we need more of modeling at our own faculty. So I have many questions, but I will ask only two. Which modeling codes you use for periodic and molecular DFT calculations?
Yeah, quite a lot. So personally, I started with Quantum Espresso.
Yes.
Then in my postdoc, I switched to VASP. They had the license,
Yes.
and it's faster in my
Yes.
experience. But now for the photocatalysis, my students are using GPO mostly.
Sorry?
GPO
Oh, yeah.
Yeah. from DTU.
Okay.
Yeah.
Yes, and I saw that you use hybrid density functionals, HSO6.
Yeah.
Did you use that in Quantum Espresso?
No, in VASP.
Oh, that's okay.
Yeah.
Thank you very much.
Thank you. Another question? Aisa, okay, please.
What I'm going to ask perhaps has nothing to do with what you presented, but with what I need. So,
I can answer.
can you model when atoms formed, let's say in a plasma, hit the surface and then recombine on the surface like Langmuir-Hinshelwood or Eli-Riedel mechanism? Can you model that? And especially if they can recombine into excited states.
Yeah,
Do you think that it's possible to do that with your technique?
This is a very good question, because we have a European project that works with that, and I have a postdoc who has been tasked with modeling plasma used for ammonia synthesis. So I can't answer you at the moment. So I mean, the answer in principle should be yes. At least I hope. Otherwise, we have a problem. But I don't know the specifics. So how to do it, that you should ask me in half a year. Yeah. But looking at the literature review we've done, people mostly just pretend that excited states don't exist. So they just do everything on ground level, even if it's plasma or if it's photocatalysis or whatever, and then they claim that this is somehow relevant to the system at hand. It might be, but it would be better to include this.
Recombination to excited state of N and O is more than 10 times faster than recombination to the ground state on the surface. So
that's why.
Thank you. Is there any questions? More? No? Thank you, Dr. Hush. Now we continue with another invited lecturer, Dr. Stevan Markovic. And before he starts, we hear some short information about him.
Dr. Stevan Armakovic is a physicist with expertise in computational materials and molecular modeling. He applies atomistic calculations to understand the structural, reactive, transport, and optoelectronic properties of various molecules, inorganic nanomaterials, ionic liquids, polymers, etc. He applied a vast number of computational tools for atomistic calculations, including but not limited to Schrödinger material science suite, Jaguar, Desmond, and macromodel programs, games, Orca, PSI4, SCM, AMS, Quantum ATK, Quantum Espresso, Autodoc Vienna, Gaussian, etc. He is currently affiliated with the Department of Physics, Faculty of Science, and of the University of Novi Sad, where he teaches various physics courses. He's also a member of the Computational and Analytical Chemistry of the Environment Group, where he is in charge of the computational modeling of materials. He also teaches selected physics courses for students with exceptional abilities in physics at the Jovan Jovanović Zmaj High School in Novi Sad. So far, he has published more than 130 papers in journals with impact factors, while according to the Scopus database, he has been cited more than 2,500 times with an H index equal to 30. Stevan is a verified peer reviewer, Web of Science, with more than 350 pre-publication reviews for journals with impact factors, and has been awarded several times as top reviewer and excellent reviewer. He also reviewed grant proposals for National Science Center Poland and South African Medical Research Council. He also reviewed 2 book proposals for Elsevier. With Dr. Sanja Armakovic, Master of Science Maria Uzelec, and Nikola Savanovic, he has established an NGO devoted to the international development of academic and scientific collaboration, NIDASCO, to which he serves as the president of the board. Stevan is also the developer of Atomistica.online, an online molecular modeling platform he co-founded with his wife, Dr. Sanja Armakovic. Let's give a warm welcome to Dr. Armakovic.
Thank you very much. Hope you can hear me. Yes. So, dear organizers, thank you very much, and dear attendants and dear guests, thank you very much for coming to this lecture. I would like to sincerely thank the organizers for organizing this great event. I would also like to thank the organizers for organizing the fabulous party last night. And the last night party tells one very important thing about scientists, and that is the fact that scientists are in very good shape for partying. So we show the world that we know how to party also. So I will be remembering this conference for at least 2 reasons. The first reason is that I'm finally here at Jahorina. So far, I have been participating within this conference as a co-author, but this is the first time that I'm physically present here. And the second reason why I will be remembering this conference is that for the first time, I will not present original research results, but I will present the scientific product that I have been developing in the last year with my wife, Sanja. So today I will be talking about our molecular modeling platform, and the name of this platform is Atomistica Online, meaning that you can do everything online for free. Of course, it is in the initial development stage, and in the months and years to come, I hope that we will make more tools and make it more valuable for both teachers and researchers. So the fact that I'm presenting the molecular modeling platform imposes the necessity to say something about molecular modeling. So molecular modeling is a branch of science that deals with prediction, and we all know how prediction is meaningful these days. These days we are also interested in the prediction of the Euribor rate, and people who have the bank loan know what the Euribor is. So we try somehow to predict the properties of molecules just by taking the molecular structure as an input. And how do we do that? Well, we do that by applying atomistic calculations. So atomistic calculations incorporate atomic level information to provide macroscopic properties. So whenever you hear in the literature the keywords like DFT calculations, ab initio calculations, molecular dynamics, all those calculations are atomistic calculations. So that is the reason why we decided to name our platform Atomistica. And it sounds cool. So we start with the, I'm risking, yes. So we start with the input structure, and then we apply atomistic calculations, and we obtain properties. For those who like more the operator form, we can think of atomistic calculations as some kind of operator, and we act on the input structure, and then we receive properties. So it is very important for real-world problems to be able to predict properties of molecules, periodic structures, etc., etc. So atomistic calculations in literature. Every breakthrough in material science is followed or complemented by DFT calculations or atomistic calculations in general. So I took one simple example, for example, the molecular imaging, and you see the journals where these results have been published. And in all of these, for example, in all of these journals, the atomistic calculations have been applied. So we have a clear motive to develop products involving atomistic calculations. What can be obtained via atomistic calculations? So practically in the material science, you name it, you can almost deal with almost everything applying atomistic calculations. These are just some examples, and I'm belonging to the EEMOS research group within the Faculty of Sciences. So this is what we most frequently apply. We use atomistic calculations to study the frontier molecular orbitals, to study the charge distribution, to predict UV spectra. Then we apply molecular dynamic simulations to understand hydrolysis processes or how our pharmaceutical molecules interact with proteins. And then we also apply periodic DFT calculations in order to understand band structure and properties of photocatalysts. So what is the basic workflow in molecular modeling? I want to show what do you need to do in order to apply molecular modeling, and then you will get the clearer picture of our scientific product. So first of all, you have to have an input. And then you subject that input to the code that you are using. And literally, there are hundreds of codes for atomistic calculations now present in the market, both free and commercial. So in the step 3, after if your calculation converges, you receive the output file. So what is important to mention is that input file is a simple text file, and the output file is also a simple text file. So that is really nice. Let's see how this works on a simple example. So let's say that we want to perform some kind of calculation on a simple methane molecule. So this is how input file looks for CH4 molecule. Then we subject that, for example, to ORCA modeling package, the modeling package that we use very frequently. And this is what we get. This is just a piece of output produced by this calculation. And if a beginner looks at this output file, or if some experimentalist looks at this file, and he sees just lines of text and numbers, and this means practically nothing if you want to quickly make some progress, to quickly explain some kind of process that you're investigating. So what you have to do with this output file is to post-process it, to use some additional tools in order to get some results that can be commented in your, for example, paper, or if you are addressing some kind of process that some company hired you to do. So it is not difficult, but you have to fulfill a few steps. So tools of the trade. What do we have different kinds of tools for molecular model, and we can separate them in 2 main classes from the aspect of functionality and from the aspect of availability. So from the aspect of functionality, you have tools for molecular modeling that can only generate input files. You have tools that can only analyze output files. You have tools that you have only molecular modeling code that can run those atomistic calculations. And then you have, of course, combinations. So all kinds of tools are available. From the aspect of availability, it is important to mention that we have the so-called open source solutions. We have free for academics solutions, and then we, of course, have commercial solutions. And of course, the best and the most efficient way is to apply some kind of commercial solution. But the problem is that we all lack financial resources here in the Balkans. So we firstly refer to open source and free for academics tools. This doesn't mean that these tools are less powerful than commercial tools. Trust me, you have even some open source and free for academic tools that are even better than some commercial tools. But the real thing is that if you're a beginner or some kind of experimentalist that want to involve modeling in your research, the most likely you will start with open source and free for academic tools. And this is where we want to develop tools for the beginners within the Atomistica Online. And this is what we have done. So these are just some examples of the tools for molecular modeling that are present on the market. I want just to draw your attention to this this fantastic molecular modeling tool called Orca. I will refer to that tool somewhat later. All of these tools are free for academic use. And of course, the thing with atomistic calculations is that these tools have really good and attractive logos, so I couldn't resist placing them on one slide. So, a few words about Atomistica Online. You can visit it on this website, https://Atomistica Online, and initially, we wanted to make just one tool, and we initially made just one tool, input generator for the Orca molecular modeling package. And we worked for some time on that, and we used only Python programming language, and then we had to use the Anvil platform to make our Python programs available as a web application. So if we have programmers here, you know that Python is very, very powerful for calculations, for data science, but it is really a challenge to make a web application with Python and nothing but Python. So we made some codes for calculations, and then we were a little bit disappointed because we didn't know how to place those tools on our website. And fortunately, the Anvil platform, risen out of the nothing. It is a UK company, and you can use the Python programming language and their drag and drop builder to build web applications. And it is what is the most important, not just that you can use nothing but Python to make applications, but you can deploy your web application on your website in a matter of 2 or 3 mouse clicks. So when we finished that, we firstly sent that link to our collaborators, mainly from India, who are applying a vast number of atomistic calculations. And we wanted to have a feedback from them. And then we decided, then Sanya and I decided, well, the feedback is really positive. Let's make a paper out of this, and let's play a little bit. Let's do something that we have never done before. Published a paper in a journal with impact factor without research results. So it was an experiment, and we saw that there are some journals that allow you to publish, for example, your software and some of your tools. So we described the capabilities of Orca input generator, and we submitted that to Molecular Simulation Journal. It is the journal involved in heavy atomistic calculations, in heavy modeling of all kinds. And we received positive feedback. And you can see that this journal has a decent impact factor, taking into account how specific topics are covered with this. So this was just one tool. And I want to explain why we decided to make tools for the Orca modeling package. Because Orca has a simple syntax. It is probably the most powerful molecular modeling code, not just because it is free for academics. It is a closed source program, meaning that you cannot see the code, but it is free for academics. And you can see the code if you, of course, pay certain financial, if you invest to the developer. It is a German project. Professor Frank Nesses stands in front of this project, and it has been developing for more than 2 decades. And it is, as I said, it is easy to use. It is free for academics. The input files have simple and intuitive form. And what is most important, beginners prefer to start with Orca. So if you visit some forums, if you visit conferences, people dealing with molecular modeling and atomistic calculations and molecules will most likely suggest you to start using atomistic calculations with the Orca. So it has, regarding the molecular modeling task, you name it, Orca can do it. Regarding the methods, this fantastic program covers some methods that are not even available in expensive commercial solutions. And regarding computational details, you can play all night like we did last night. So from the aspect of functionality, what kind of tools do we have within Atomistica Online? So we have tools for generating input files for ORCA, for XTB program, for MOPAC 2016, for Sci4, and we also implemented and installed the JSMOL molecular visualization tool. It's difficult to pronounce that. And we started with this, and then we made this, and we also made tools to analyze the output files. So when you run atomistic calculations with ORCA, you then want to have, you don't want to have and to deal with just with that output file full of text, because that will tell you nothing unless you're a pro. But if you, for example, right now you can use our tool for analyzing output, and you can plot infrared or UV spectra, which is important for our research group. Of course, many tools are on the way. And what is great is that this tool for analyzing output will also be able to analyze your output files made with GAMES and Sci4, which are also great solutions for academics. And of course, we have nothing can pass without Gaussian, of course. And it is most probably the best known commercial molecular modeling package. And of course, what distinguishes Atomistica Online from other solutions is that you can run calculations online. And of course, you cannot run all types of atomistic calculations because atomistic calculations are computationally expensive. But what is great, there is a part of the scientific community that is devoted to developing semi-empirical atomistic calculations. Those calculations are extremely fast, and they are not as accurate as, for example, DFT level of theory, but they can reach the accuracy of DFT in terms of geometrical parameters. Of course, not all elements from the periodic system of elements are covered, but still it is something that distinguishes our scientific product from other. What is great is that the XTB program made by the Professor Stefan Griemer from the University of Bonn is completely free. You can use it freely in industry, for commercial projects, you can use it for academic activities like we do. And what we did, we made a web application that will allow you to run XTB calculations on our computational server. And another great semi-empirical code is MOPAC 2016. The problem, for example, I'm quoting, the problem was that MOPAC was free for academics, but it wasn't open source. So initially we couldn't make this web application within Atomistica Online. But just as soon as we finished with testing of the XTB online, we received the news that MOPAC 2000, that the creator of MOPAC 2016, Dr. James Stewart, decided to give his program to the scientific community for free and made it open source. And that opened doors for us to also make a web application, thanks to which you can run atomistic calculations with MOPAC directly from your web browser. So I repeat, there is no need to install anything. Just go to Atomistica Online and you can use these tools. And we also made some other tools. I will mention them. Of course, there's no enough time to present all of these, to present all of these tools. So I will present just some of them. And in the modeling community, it is, and in the programming community, and it is popular to say, we will show you our flagship tools. So this is the web page of Atomistica Online, and there are several tools. Online calculators are developed separately because, remember, we are not programmers. We are scientists dealing with materials modeling. And so it was easier for us to develop online calculators aside of the main Atomistica online calculator, aside of the main Atomistica web application. So if you go here and click Start Atomistica Online, I just want to once again remind you what ORCA input generator is. So remember, I said that in order to run atomistic calculations, you have to have input file. So this is our first tool. We made tool that allows you to easily make this input file. And then you run this command prompt and you receive the output. So this is how the main Atomistica Online application looks like. The graphical user interface that Anvil platform uses is the famous and best known the so-called legacy theme developed by Google. So if you click here, Orca input generator, it will lead you here. And everything is imagined to be point and click. If you like to play video games, you know those point and click adventures. So this is how you're going to make input file for the Orca. What this tool distinguishes from other available tools, and I repeat, there are no online input generators for Orca or input generators for other tools regarding molecular modeling. Regarding periodic calculations, there are present some online tools. So what distinguishes this tool is that all of these words are linked. So if you are a beginner and if you click on these links, you will get clear instructions how to set up input file. This is what we made, bearing in mind the beginners in the field. So we remember our challenges that we had when we started to involve molecular modeling within the University of Novi Sad back in 2010. We didn't know how to set up those input files. We found some input files and we ran some calculations and we got some output, but we didn't know what, and we didn't have the hints, tips, and tricks how to set up these computational details. So here you will find clear instructions how to set up your input file. And eventually, there are so many Windowses here, and eventually you will get here, and when you press generate Orca input, you will get the input file. You can copy that, or you can download that as a separate input file, and then you can run your own atomistic calculation. This is the ADME calculator, simple calculator. This is interesting for people dealing with pharmaceutical industry, because if you develop new molecules with pharmaceutical potential, you want first to calculate these properties to see whether the permeability of your molecule is right. Your molecule can have fantastic biological activity, but if it cannot breach the membrane, if it cannot move through the organism, it is useless. So what people do, they synthesize what scientists do, they can synthesize thousands, if not millions, of molecules, but they somehow need to find the best candidates. And this tool helps them. Of course, these calculations can be found on other places on the website, on the internet. So the next tool I'm going to present is the detonation properties calculator. So if you want to calculate detonation velocity or detonation pressure, if you're dealing with high energy materials, this is going to be very useful for you, because if you want to if you want to develop new explosive, for example, then you want to calculate these properties, and it can be tedious to apply Kamat-Jacobs equations. So we made a tool for that. Everything that you need to do is to upload your optimized structure and then to give information about the heat of formation and about the density. If you don't know the density of your newly developed molecule, then there are ways to calculate that. And if you don't have the heat of formation of your molecule, which is tedious to experimentally determine, you can use the online MOPAC calculator that we also have developed. So the next tool, this is this is just how it looks when this tool gives you the values. And this is the output analyzer. You just upload the output file made by Orca. And if you set right the input parameters, then you can receive UV spectrum or infrared spectrum, depending on what you have placed in your input file. This is how it looks. You can export it in PNG format, or you can export it in the SVG format. Then you can use some freely available program for dealing with vector graphics to finally adjust your figures. This is what we are very proud of. So this web application connects the XTB program made by Professor Stefan Grimme. Professor Stefan Grimme has more than 100,000 citations, and his contribution to the scientific community is absolutely fantastic because everything is completely open source and free to be used. So you can use this tool to set up calculation details, and then you just press run. And the only limitation within R2 is that your molecule should be having less than 100 atoms, because our current server resources are a little bit limited. So if your molecule has, for example, 50 atoms, the geometrical optimization will be finished in 15 to 20 seconds, for example. And as soon as we improve our server resources, we will remove that limitation, so you will be able to run online calculations with structures larger than 100 atoms. But we think that if you're developing new pharmaceutical molecules, or if you are, for example, studying absorption on graphene surface, it is enough to have that limitation of 100 atoms. So this is how it looks like when the calculation is finished. In this case, we requested only energy calculation and some and calculation of ionization potential. Here we can see that the optimized structure is reported here, so you can download the optimized structure and then use this optimized structure for your further, more detailed calculations, for example, with ORCA. And that is what multi-scaling is, what Dr. Kush mentioned. So you want to combine levels of theory. You can use these types of calculations to pre-optimize your molecule, and then to use and then to perform more detailed calculations on the already optimized structure. And I want just to mention that semi-empiric levels of theory works very well with, for example, organic molecules. So to sum up everything, Atomistica Online is free, and as the Facebook says, it's free and will always be free. We don't run ads on our website. This is perfect for teaching because you do not have to install or maintain anything. Your students are able to you just need to prepare structures of the molecules that you want to investigate, and then you can upload everything on the website and use the complete platform directly from your web browser. As far as we tested it, it works on any kind of web browser currently available, and it is mobile friendly, not thanks to us, but thanks to the Anvil platform, which is absolutely fantastic. And you can perform modern semi-empirical calculations with XTB and MOPAC 2016 directly from web browser. And this interface is suited especially for the beginners in the field, but this doesn't mean that professional users cannot use this, because professional users, remember, they combine levels of theory, so there is no need to pay some expensive solution for semi-empirical calculations. It is you can use Atomistica Online. What are our next steps? Our next steps is to fill the website with tutorials, with manuals, with explanations how to use these calculations in your real world problems, how to use it in industry, in all sorts of industries, and you can check this website. I would like to thank the research group to which I belong to. Both Sanya and I have full support from our members, and we are very thankful to them. We are the EMOS group within the Faculty of Sciences, and there are members from other institutions within this research group also. So thank you very much. And in the end, I would also like to thank the IDASCO NGO, which we are running. I invite you to visit this website and to check our activities. And thank you very much for attending.
Dr. Ermakovic, thank you very much for bringing these very popular topics to us. There are some interesting tools also for our research, so I'm very pleased to hear this. And I would like to open discussion. Is there any questions? Okay, please.
I have liquid mass spectra, okay?
Oh.
Mass spectra.
Yes.
We can, I don't use yet this website, but I will just try.
Yes. You will.
Yeah, so it's easier, we find molecules with these specters in there.
There are some tools for identifying the mass spectra.
Yes,
Precisely made by Professor Stefan Riemer within the XTB, not within the XTB program, but there is, they built a tool that combines molecular dynamics and these semi-empirical atomistic calculations to obtain the mass spectra. And I tried to run that, and for some reason it didn't work, most probably because I was trying to use that on the Windows machine. So I'm not very fond of the Windows. People dealing with molecular modeling prefer Linux, and but that is very interesting, and that is going to be one of our next steps, definitely, to try to simulate the mass spectra, because that is also important when we identify the degradation intermediates during the photocatalysis. So excellent question. But what you can do is to, if you perform the mass, if you have experimentally some guess of the molecules, you can run DFT calculations or atomist or any kind of atomistic calculations in order to get the reactive properties of your molecule, of your molecules. And then you can make some conclusions about the mechanism of degradation, for example.
yes, sometimes.
Yes.
Okay.
As Dr. Kush mentioned, usually people perform these calculations on the ground states. It would be more accurate to involve excited states as well. But I think that it is a good starting point for experimental groups that are in the beginning of the involving both atomistic calculations in their research.
Okay. Another
Yes.
question. This is an interactive site.
Yes.
If, for example, I have a standard and my mass spectra is not there, I can upload or not?
You cannot upload your mass spectra right now.
Okay.
We don't have, so far we didn't build tools for mass spectra, but it is quite possible that in the next few months we develop tools for building input files for that tool for analyzing mass spectra or simulating mass spectra.
Okay.
So because it is a combination, that tool made by Professor Stefan Riemer, it combines molecular dynamics and semi-empirical calculations. So it takes some time, but it is quite useful, you know, because if you have the power to predict the mass spectra and then compare with your experimental results, that is something that reviewer would be fond of very much. Yes, thank you for asking the question.
Another question? Okay, thank you, Dr. Markovic. Now we have coffee break, please.
Ladies and gentlemen, we now start the second session of our talks for today. I now invite the members of the working presidency to join us here. Just a moment. Professor Ophelia Anjos, Polytechnic Institute of Castelo Branco, School of Agriculture, Portugal. Carmo Horta, Polytechnic Institute of Castelo Branco, School of Agriculture, Portugal, sorry. And last but not least, Nataša Milić, Professor Nataša Milić, University of Novi Sad, Faculty of Medicine, Department of Pharmacy, Novi Sad, Serbia. Let's greet our members of the presidency with a warm welcome.
Good morning to everyone. I will begin the second section of today with a very nice panel. And we'll invite the first talk is made by Rui Costa from Polytechnic Institute of Castelo Branco. But first we'll listen the short biography of the professor. Please, could you read?
Professor Rui Costa is highly experienced food scientist and engineer. He holds a master's degree in food engineering and a doctorate in biotechnology and food engineering from the Catholic University of Portugal. Since 1999, he has been a professor at the Polytechnic of Coimbra, Portugal, on food technology and food engineering. He has a large experience in food process optimization and food quality, developing work on new protein sources, insects, seaweeds, and legumes, and food waste valorization, and coordinated projects in codfish processing and its waste valorization at the incorporation of seaweeds in pasta. He frequently is active in the organization of international scientific conferences and member of the scientific committee of 10 international conferences and co-chair of the 2014 ISECI International Conference in Athens. He coordinates the EU-funded project EQ Vegans, Sector Skills Alliance, European qualifications and competencies for the vegan food industry, was involved in over 15 European projects and acts as an expert for European Institute Technology and European Education and Culture Executive Agency. He currently holds several leadership positions, including the Secretary General of the ISECI Food Association, President of European Alliance of Subject-Specific and Professional Accreditation and Quality Assurance, member of the Executive Committee of the Research Center for Natural Resources, Environment and Society. Let's give a warm welcome to Professor Costa.
Thank you. Professor, we have 45 minutes. Please, if you can give your talk in 40 minutes to have 5 minutes for questions. Thank you very much.
Thank you. So, thank you very much. Thank you very well. Thank you very much. Sorry, this is like a joke in Portuguese of people speaking in this way with these words. I want to thank the organization for inviting me for this talk, and also on behalf of the Executive Association, I'd like to say that we are very proud of being collaborators of this organization and open to continue to collaborate with this Congress, and also in other opportunities that we may have with the University of East Sarajevo and also the other universities that are co-organizing this event. So I will speak about the seaweed in food, opportunities and challenges, and we'll start by trying to clarify what I'm talking about, because not all of you may know exactly what I'm talking about. So I just first give a slide about taxonomy of seaweeds. So seaweeds are not plants. Some people call it plants of the sea, but in fact, they don't have true stems, roots, the vascular systems. So they are eukaryotic organisms, and they can be classified in different kingdoms according to the classifications. There are classifications of 3 kingdoms or of 6. So they may be in the Protista kingdom or in the Plantae kingdom. By algae, also there are others, microalgae, that are part of this big group of algae. But so here I'm just talking of the seaweeds that are algae. they look like plants, but they are not plants. So for the three main groups of seaweeds are the green, the red, and the brown. You can see here some examples, and you can see also how they are classified in terms of phylum, classes, order, family, genus, and species. So most of the time we'll talk about species in terms of species, but sometimes it's very difficult to distinguish them, to identify them. So we can also refer to the genus. So you'll find similar classifications for the red and for the brown algae. I would like to ask you, do you eat seaweeds? Who eats? Can raise the hand? Okay, 20%, 30%. Exactly. So you usually try travel and try to eat it. But also here you can have seaweeds because there are restaurants for that. In Sarajevo, I saw in the internet several that, you know, the typical sushi restaurants, they introduce the seaweeds all over the world. So what is the importance of seaweeds? The seaweeds are used as food, but not only. So here I'll just give a brief slides on that. They are used, apart from being used as food, they are used a lot of phycocolloids. They, you know, agar-agar, carrageenan, they use them a lot in the lab and also in food. They can be used as fertilizers, as feed, in cosmetics, in nutraceutics, and pharmaceutics, and in energy. And they have completely different values for these purposes. They can go as low as 1 to 3 euros. I think here it's twice the Bosnian, or half. But you know, twice. And here we have 1 to 3 euros, 10 to 130 for human food, and can go around to 400 euros per kilo if used as a pharmaceutical product. These are values given by the company that which I worked with, Alga Plus from Portugal in 2018. Seaweeds, I'm talking about seaweeds, but seaweeds is one of the several big trends in food nowadays. I could select here 5 very big trends. Plants, although they already existed a lot in the past, but now they are being consumed more. You know, there is a big trend on veganism and towards reducing the meat consumption. Cultured meat is not in the market yet, but it was already approved in Singapore and the United States. So there are those countries, they invest a lot on the research on cultured meat. Insects, not so attractive for most of the consumers, but now recently introduced in Europe. You can find already in many supermarkets some products with insects, not usually entire insects, but after being milled and mixed in products. And also fermentation. Fermentation, it's now a big trend also to produce products rich in protein. And seaweeds, of course, the topic of this talk. This is related with also a consumption, alternatives for consumption of the reduction of meat and the reduction of intake of animal protein. If you look at this intake, you can see there is a lot of variation according to the GDP per capita. Here, I don't find Serbia because we need to amplify and Bosnia, we need to amplify the plot, but probably will be in this zone with a high content of meat, of a high intake of meat. But you see, there is a big possibility, even for the same income, to reduce the meat intake. And this is really a big trend, and that's why we are talking now about a big investments in
plant-based alternatives to meat, fermentation, and cultivated meat. And you see the investments are, of course, very big on plant because it's more easy now to produce. A lot of research is needed for fermentation and cultivated meat. Insects come after this, and more or less at the same level of seaweeds, although we have a little intake now of insects in 2022, it will increase in the next 10 years. But let's go to seaweeds. In seaweeds, you can find several types of products. Of course, apart from the sushi restaurants, these are examples what we have in Portugal. Fresh seaweeds, they are refrigerated, and so you can find it in some supermarkets. Dried seaweeds in milled, so in flour form. Some mixed with other products like fish in sardines, and some used as supplements. They are extracted, subject to extraction, and then concentration and lyophilization, and then the powder is rich, for example, in iodine. So the current seaweeds, they fit in several current food trends. One, they increase biodiversity. You know that we eat very few diverse number of foods. We have been reducing that, and now there is a trend of increasing that biodiversity intake, and so they fit in this objective. Also, they have high environmental sustainability standards because they can grow and uptake oxygen, phosphorus, carbon, and also other organic compounds and carbon dioxide, for example. They can help us reducing the animal intake, and also they can help us reducing the salt and sugar intake. And they can be used as convenience foods and fit to nutritional daily routines. So first, when you're talking about seaweeds, it's important to look at the cultivation of seaweeds, because this is currently a big limitation. Currently, the two big limitations to the consumption of seaweeds are the consumer is not used to it, so they don't accept it easily. And also there is not enough, if imagine all the consumers want seaweeds, there's not enough seaweeds for all. So there's a bottleneck at the level of the cultivation of seaweeds. And you can see here from the agriculture, of course, agriculture is the only solution to increase that offer of seaweeds. And you can see here they increased a lot from 1992 to 2020. And you see there is a big increase on the offer on agriculture of seaweeds, as it happens also in the other animal seafood options like fin fish, for example, the biggest part. Aquaculture of seaweeds is higher in Asia, in China, Indonesia, and Indonesia is this red one. Also a lot in Russia, India, South Africa, but also it can be harvested from the nature. So when it is harvested in fisheries, you have it from Australia, also Indonesia, also Russia, and North America mainly. In Europe, there are currently some cultivation of seaweeds. You can see here, like in France, Spain, Portugal, north of Spain, again, also Ireland, Scotland, Norway, and Iceland. So seaweed aquaculture is very interesting because, apart from being the only way to increase the seaweeds production, it's a sustainable source. So it requires no fertilizers, no pesticides, and no fresh water to grow. Also, it's a carbon sink. It absorbs carbon dioxide from the atmosphere and do not need land. So we can use an explored area of the planet for the growth of seaweeds. So there's no competition with the other terrestrial crops and with natural landscapes. And also it contributes to the removal of nutrients from like carbon and phosphorus, which can in excess cause environmental problems. It can be done in land-based, like here in this picture, you can see from a Canadian aquaculture plant, and also or from the sea, what is called mariculture, like you see here, Kappa Ficus farm that you can find in China, Indonesia, Philippines, Korea, Japan, and Chile. I showed what the company with which I collaborate. It's Alga Plus. It uses an integrated multi-trophic aquaculture where it grows in parallel fish, sea bass, and sea bream. And when they are captured, the water is used in these tanks to cultivate the seaweeds. So then the water is renewed and goes back to grow, cultivate the fish. What are the most big groups of seaweeds for consumption? For production, you can see here many use they are cultivated for the use of carrageenan and for agar, as you can see here. Apart, they can be captured in the nature, but in terms of agriculture, they constitute more than 50%. And for food, we can find here mainly what you already know, nori or porphyrin that you find in sushi. You can use, you can find also wakame in sushi. I have this almost every week. And also you can find Laminaria japonica. It's very famous in Russia, especially in Far East. What are the uses of seaweeds? The seaweeds, they are first reared from seeds, then they are grown in tanks. After that, they can be taken to the sea, and when they are harvested, they can be used. They can be subject to extraction. They can be used as fertilizers, and they can then be used also as feed, and then finally, the purpose of this presentation, they can be used as a food. And in food, they can be first stored in the seawater, for example, or in controlled water storage, or they can be preserved by pH. It's a common preservation method in food. They can also be preserved by salt, and they can be dried, also the most probably used and common method of preservation. And of course, they can be frozen. This is natural. It's a common method of preservation of foods also. And of course, you know that is very expensive. In terms of packaging, I just want to call, because this talk is about talking about challenges and opportunities. In terms, there is little research on packaging. One research that I found that it speaks about the shelf life of seaweeds packed in polystyrene containers without seawater, and a study did many years ago about iodine permeating packaging materials. So this is really relevant because iodine is a main component of seaweeds, and it's very important for our health. But it is present in very high contents in seaweeds. So if you eat too much seaweeds, it will have problems. But iodine, at the same time, if it is packed in seaweeds that are packed, some of it may be lost according to the type of plastic material that is used. So seaweeds, what are the main components? We're talking on our seaweeds for food. What are the main components of seaweeds? Water, fiber, and protein make almost all the content. So of course, this varies a lot according to the species. according to the time of the year when the seaweeds are harvested. And so it's not the width, let's say, of the interval of the values are large. So water, fiber, protein mainly are the main components. Of course, then it has also other compounds, minerals, vitamins, etc. Some highlights on the valuable components of seaweeds. Here I have here the names in Portuguese. Not interesting for you, but you can look at here the brackets. Between brackets I have the genus name. So ulva, this is the sea lettuce. It's also called like sea lettuce. Has high in protein, calcium, vitamin D, and iron. Codium high in omega-3 and omega-6. Fucus high in fiber, iodine, iron, magnesium. Then porphyra, nori, the one from sushi, high in protein, vitamin A, vitamin B12, omega-3 and 6. Palmaria, also protein, vitamins K and C, and folic acid. And Gracilaria, high in protein, potassium, magnesium, and iodine. So protein is in almost all of them, as you see, and iodine is also present in most of them. Seaweeds are recommended to be in the large group of consumption of fish. In fact, now when we eat fish, seafood, we eat mostly predatory fish, salmon, for example, tuna, and these herbivorous fishes. But we are recommended to eat more oysters, mussels, and clams and seaweeds than what we eat in fish. This is an advice. And also seaweeds, you know that they are really related. They are now being sold, let's say, as a superfood. When you look at the sustainable diets and people that live long, you find in some of or many of those environments the consumption of seaweeds. So they have this image of being a superfood. So when we try to incorporate, what are the benefits of incorporating seaweeds in food? First, it can enhance the flavor by adding umami taste and natural saltiness and chewiness. This is you can enhance this, but you have to be careful not to put it too much, because if you put it too much, there will be rejection. We can reduce sugar and salt content by using these seaweeds. We can increase the nutritional value by adding, because it has vitamins, minerals, antioxidants, etc. Also, it can support gut health due to probiotic fiber that it contains. It especially can support thyroid health by providing iodine and other benefits like anti-cancer benefits, for example. We already spoke about sushi. Sushi is one of the four main, let's say, groups of foods that includes seaweeds that you already know. Sushi, if you go also to these restaurants from Asia, you also have foods with soups with seaweeds and also salads. And sauces would be the fourth main group of foods that contain seaweeds that nowadays are consumed. But there is already an offer of seaweeds introduced in many other foods, mixed with beef, pork, chicken, seafood, bakery, pasta, fruits, vegetables, dairy, and so on. So you can mix with them. And nowadays there is a lot of development of new products of introducing seaweeds. Here I show just some pictures of seaweeds-based snacks. You can find it in the shelves. Or of meat products, meat in bracket. They try to substitute meat, but so you can see here these sea veggie burgers, and also, for example, seaweeds based in dairy products like this one, or of butter mixed with seaweeds, or cheese mixed with seaweeds. It's an interesting product. If you, in the liquid form, you can find also concentrates, mixed in olive oil, and this one is not for food, is for skincare, also can be used for pharmaceutical purposes. Overall, how much seaweeds these products contain? They can go to very, very low amounts, like 0.01% in olive oil, and 1 to 4% or even 6% in snacks, cereal bars, cookie, pasta, breadsticks, and bread. And there are studies that present biscuits with 30 to 60%, which is a very high amount. Myself, we did in our lab, we did studies on pasta, and I'm showing some slides on that. We tried to incorporate seaweeds in pasta. We used Fucus vesicuosus that has several health benefits: hypothyroidism, anti-estrogenic benefits, anti-cancer, blood reduction, etc. Also uva rigida, that is the sea lettuce, antioxidant, promotes bone health, weight loss properties, gracilaria. So this is a brown, green, red seaweed, and has anti-inflammatory effects, antioxidant, etc. And also porphyra, which is known, skin renewing, repair and protection, anti-cancer potential. We tried to, the strategy was to enrich pasta with these health benefits of seaweeds. So what did we do? We usually, it's easy to make the pasta. You have the flour. Usually it needs a good protein to sustain the pasta. So usually it's made from wheat. And then we mix it here, a little percentage of seaweeds. We mix and extrude it, then we dry it, and then we cook. First thing we can see is that when you use seaweeds, you need to add more water. So in that mixing phase, you will need more water. If you put 1%, you don't need, but if you put 5% or 10%, we'll need up to 40% more water. First, this is the first result. Then here it's after drying, you can see here the look, the color, more brown, 1%. And of course, when increasing the content, the color, it's more dark. What are the losses during cooking? Was the texture good? What was the sensory acceptance? Those were was the criteria for us to define if the seaweeds were acceptable, if these products were acceptable or not. We studied also the protein, and we saw that, of course, if you add, for example, gracilaria, the protein increases. This is a good benefit. But the problem is, although the protein increases, the gluten content decreases, and this is a problem for the preparation of the pasta. In terms of uva, there is not much increase of protein. So the gluten content decreases, and this causes problems after that in the process. The fiber, it increases a lot in all seaweeds. This is easy to see. So more seaweed content, even 1% will have a higher amount of fiber. In gracilaria or in uva, you'll see 1%, it's enough already to see an increase in fiber content. Then, well, there were some letters here, but they will change, is the cooking quality. So the cooking quality, how do we see it? Again, okay, this is optimal cooking time. How do you see it? Very, very simple. Just put between two glasses the cooked pasta, and if it is not cooked, if you see this center, it's not cooked, it's more opaque, while this one is more translucent, so it has more water. When, well, I had an animation, but it disappeared. We will push it, and then we will see, we'll stop when on the zone that is not cooked. So when it, so we will see from, this is from the side view, from the top view, we'll see like this. When it is completely cooked, we can compress it, and it will until the end. So compressed it totally. So that's when it is cooked and we register the time. So after that, we could see, for example, that here the behavior is different. We will see zones, zones that in the center are well cooked, but others that are not. We could see, and so we could see that the optimal cooking time was increased, and even with 1%, it increases a lot. It increases around 30%. So, and we could see that what is the problem is that around the fibers, they absorb a lot of water, they compete for the water, and they, let's say, dry or don't let the granules of starch that are surrounding them to gain water. So they are competing for this. At the same time, of course, so this is well seen here and also here around this fiber. So, and you can see this part is very humid, less dark. This one contains less water, is not cooked. So this is the problem of the fibers. The fibers retard the cooking. And so this is a problem in terms of cooking time. It delays the cooking time. And so it means that also to cook it, we will have more losses because we are cooking more time. So if you have more losses, the nutrients are lost to the water, which is not beneficial. We could see this loss so increases a lot according to the content. If the content goes from control to 1%, 5% to 10%, you see the losses increase in all 4 seaweeds. We don't see a big difference in mass gain because you are cooking more time, gaining more water, and losing more solids. So there's not much difference in mass gain. In terms of hardness, the ones that have more fiber will be less hard. And what limits the consumption of seaweeds is the sensory acceptance. You can see here overall for the 4 seaweeds, if you put 10%, they have a big rejection. If you put 5%, they have less rejection. If you put 1%, they have even less rejection. And if you put no seaweeds, they have no rejection at all. So and this is very related to the culture, the gastronomic culture of the country. It's inevitable. So for us, we will say that the technological and sensory limits are around 1%, which is common in pasta. So pasta that has tomato and other ingredients, they usually have a mixture of these ingredients of 1 to 3%. So this would be also our advice to mix it at 1%. I don't know, Ophelia, how much time do I have? Okay, challenges and needs. First, iodine. You have to, in terms of safety concerns, we need to be careful about iodine. We should not eat too much seaweeds, so they can cause thyroid problems. Second, so I will skip one slide here. Second, heavy metals, if they clean the water from carbon, from phosphorus, they also clean it from other non-desirable compounds like arsenic, mercury, cadmium. Also, there is no law at the moment, at least in the European Union, for the limits to these components in seaweeds. There is only for fish, but not exactly for seaweeds. Of course, the microbiological hazards can also occur, physical hazards, and others like allergens. Allergens, in principle, they are not present in seaweeds except from the ones that come from shellfish. So because they live in the sea, they can catch these parts from shellfish. And of course, they can also accumulate micro and nanoplastics. That is now a big issue nowadays. I will skip this example. Yeah. Another problem here in seaweeds is that there is no regulation. So there is no uniformity or consistency on how seaweeds are classified, cultivated, and harvested and processed. And so this is especially important in the case of these toxic components. Even iodine can be toxic. For example, if it's 5 grams of certain seaweeds, this can be too much, even 5 grams per week. There is a lack of analytical methods. They are currently being defined, and there is a potential loss of biodiversity because in the nature you can capture all the seaweeds you are able to. In terms of challenges of increasing consumers' acceptance, this unfamiliarity with seaweed taste is the biggest problem. So this, with time, it will be overcome. And of course, there are several tactics, strategies to overcome this. And avant-garde restaurants already use that as gels, for example. In the case of Nordics, they focus a lot on local sourced plants and species, and so seaweeds are among them. And also this superfood trend, it can also help. Also, a problem is now, if you want to increase the production of seaweeds, some of them, they must be domesticated. And this is a problem for biologists, not for food technologists. And it takes a long time to do it. So they have to go through several steps in order to cultivate it. Just to finalize, about the European Union and seaweeds. So there are now a big trend that the European Commission is trying to push to increase the production of seaweeds and the consumption. You can find, if you look for these documents, you can find many guidelines there. You can also look at the novel food catalog, where we have 22 species of seaweeds there. And finally, the EU for Algae initiative. If you want, as a researcher, you can go there and be included in a group. You can go, or if you are interested in the microalgae production, for example, or if you're interested in algae for food, etc., you can ask to be included in these working groups and try to collaborate with the team that is there. And finally, I'd like to call your attention to this project, which includes something about seaweeds on this plant-based processing. If you want to use training materials for the food industry, here it focuses a lot on alternatives to meat and dairy products, and it shows about the technology to prepare these products. So this may be interesting for you also. So I think I finalized. Thank you for your attention.
Thank you very much for a nice talk. And then I open to the audience who have questions, please.
Thank you very much for the presentation. I'm just wondering if we see some algae in nature, maybe I see tons of algae on the seasides. How we can decide we can eat this one or no? Can we make commercialization for this one?
Yeah, so first, if you know, you need to identify the algae. If you know how to identify, then you can use in Europe, so I'm talking about the laws of the European Union, you can go to this list and see if this is already accepted here. And if it is already accepted, it's easy, so you can go forward and commercialize it. But of course, if you go to the nature, you don't capture a lot, unless you go into the deep sea, where, for example, agar-agar, they catch it in the deep sea, and they commercialize. But if you go just to the coast, maybe you don't have enough to commercialize. But if you go to this novel food catalog, and you'll find that if it's not there, you can see also if it is consumed in another country. Because if it is consumed in another country for more than 25 years, the European Union will let you include this seaweed, new seaweed in this list. It's another possibility. I think that would be my advice.
The other thing, we need any permission in European Union to get any biological material from the seaside?
No, I don't think so.
No.
I'm not aware of it.
Okay, this is good then. I'm a biologist, so I can see a lot of algae on the
That can be
seaside.
used, yeah.
Yeah.
And also you need to take care about the conditions where they grow, because they accumulate a lot of toxic waste. So that's something to that's something that to have in mind and be careful.
Thank you very much.
Thank you. Another question, please?
It went a bit fast there when you are presenting the acceptance there. I would like to know what would be the general attribute that would make it accepted, because you said it's also related to culture, of course, how we behave.
Yeah.
And no, because my experience is, but it hasn't been, for example, because in Madagascar, I wouldn't come from there, and we really encourage people to use algae. But what I know myself, when I discovered first this salad, I know what it is good, but the smell or this, it's terrible for me if you put it in our culture. For me, the first time I was in there, so it smells of fishermen who fishermen who are not very clean. That was one of those, the word of this one. So that's what I was. And then when we went, people in our culture, so this is here, we eat fish as well. But how come this has not been, and of course the price if you are here, but that's another attribute here in Europe. It's relatively expensive if you compare to the quantity that you can eat or that, but you can change people's mind with that. That's, I think that's not a big challenge. Yeah.
So there are several attempts to overcome this problem of the smell and of the taste. So you have to mix it with the components that have a higher intensity, and so they they cover, let's say, this smell. This is a possibility. The other is, put it in low contents. But even in low contents, they can have a rich composition, especially in iodine, and it's already enough. These are some strategies, but it's difficult to. The main barrier, I think, is the consumer is not used to this. For example, for me, when I was a student, a PhD student 30 years ago, I was in the United States, and a colleague of mine took me to a sushi restaurant, and I hated it. It was horrible. But nowadays, I eat it once per week. So if you get used once in a while and you eat it, and you eat sushi has a lot. Also, if the restaurants they try to use it, for example, I know one in Portugal that makes a cooked rice with seaweed. It's really good. But you have the mixture of seaweeds they use. It's the competition, let's say, between the flavors, it's good, and it gives a final very good flavor. So I think also here there's a lot of opportunities for culinary experiences that prepare a very good, acceptable product, and it depends a lot on the combination, of course.
Thank you very much. The last question. To do not delay this section.
I would like just to ask one question from the point of the consumer. Personally, I don't use in my feed algae, especially seaweeds and etc. Why? Because I'm concerned in the point of hazards. If we look at our legislation, the most contaminant sea products are algae, and the ridiculous higher levels and doses of the contaminants are allowed. And because of that, I avoided products. If you look at on the regular consumers, they don't know about that anything, especially if you don't have any kind of the labeling on that products that they can warning the people about some kind of the treats, hazards, and etc. So especially from the point of the view climate changes and etc. and the problems with the warming of the cyanobacteria, blooming, etc. I would like to know, and I would like that maybe our audience to know your opinion about the benefits and threats, ratio in the points of the using that kind of the products in the everyday nutrition.
Yeah. So at the moment, as I told you, there is a lack of regulation, so that is a big concern. We can always guide a produce from the producing point of view based on the fish regulation, because in the fish everything is regulated. But so that's a problem. Also, the characterization. How do you detect the quantity of cadmium in a certain algae? What is the method? What is the most accurate method? It's not defined. So, but at the moment, people don't eat it in large quantities. So we are on the safe side in terms of that. So, and you should not eat too much. It's not something that you eat like day and night every day. No, like tomato or Brussels sprouts or whatever. No. Yeah. It's exactly. Yeah, it's a problem. We don't have all the regulations yet. So you can even, it is announced as a good source of iodine, which is good, but even that you cannot. You have to tell the consumer, don't eat too much, because it's bad for your health.
Okay. 1 second.
In the break, maybe in the break. Okay, so maybe in the break we can.
Yes, in the coffee break, because we delay a lot. Okay. Thank you very much again for the nice talking. And we move on for the second talk. And Raquel Guiné, please. Raquel Guiné comes from the Polytechnic Institute of Viseu, and she will talk about food structures and texture, industrial relevance, and measurement techniques.
Raquel Guiné has a degree in chemical engineering, a Master of Science degree in engineering science, and PhD in chemical engineering. She has a teaching habilitation in food science and a certificate of proficiency in the English by the University of Cambridge, United Kingdom. The major fields of study include food engineering, food processing, food science and nutrition, dietary patterns, and eating habits. She has been university teacher since 1994, being presently a coordinating professor at the Food Industry Department. She has been president of the Scientific Board, president of the Assembly of Representatives, director of license and master courses, head of department, and is presently director of a research unit at the Polytechnic Institute of Viseu. She is the author of 22 books, 96 chapters, 337 research papers, and 349 conference proceedings. She has presented 36 keynote speeches by invitation, 225 oral communications, and 175 posters. Most relevant distinctions for Professor Guiné. She has been listed in top 2% world scientists in 2 categories, career and single year, in 2021 and again in 2022. Global leader of a team of 76 researchers working under the international project EEM involving 18 countries, and a global leader of a team of 69 researchers working under the international project EICU Food involving other 18 countries. So let's welcome Professor Guiné.
Thank you. Professor Raquel, we have 30 minutes. If you can leave 1 or 2 questions. Thank you.
Thank you very much. Thank you for the organization to inviting me to present this work from our lab. And thank you for for resisting and being here, listening after a wonderful night we had last night. I will be talking to you a little bit about food again. And I will be focusing on texture and the relevance of these properties, because when we talk about texture, it is not only one property, it is a set of properties. Okay. So this food texture is very relevant for the whole food market, food from the industrial perspective and also from the food consumer perspective. And as I told you previously, texture is not one property, it is a set of physical properties. And these physical properties are related with the way that humans sense the products, in this case, the foods. Of course, that these properties are linked with the internal structure of the foods, and they, of course, come from internal interactions between the food constituents, and naturally that different food components and food compositions will produce different textures and feelings for those foods when they are consumed. We have been working mainly in our lab with foods, analyzing texture in foods from plant-based, but we also have done some works with animal-based products. But when we talk about plant-based foods, the texture is greatly defined by the cell walls, which are constituent of polysaccharides, and these polysaccharides will influence the rigidity and the structure of the foods. We also have texture as a main determinant of food acceptance. When we go to the supermarket and we want to buy some chips, we want them to be crispy. And when we go home, we know that if we leave the packet open, they will not be crispy and longer, and it will not be good for us. Also, when we buy a muffin, we want it to be soft. So we expect some certain properties of certain foods. And when these foods, they do not agree with these expectations, we will reject them. So we also know that apart from the consumer perspective of the textural properties, texture is also very important from the industrial point of view, because we need to know that the foods are consistent. We need to know that they are resistant. They can resist all the operations that they suffer during processing, also during transportation, during storage, and so on. And so we need to analyze these properties. Also, when we are developing new food products, it is very important to look at texture. Also, for quality control. So there are a lot of areas in the food industry for which texture is of main concern. We can measure texture through instrumental methodologies, or also using sensorial analysis through people who taste the products. Of course, that the instrumental methods are feasible, and they allow to obtain faster results. And these equipment, they include testerometers, penetrometers, and other kind of measuring units. Also to measure food rheology in semi-solid foods, and testerometers, for instance, for solid foods. And they will allow to quantify a number of textural parameters. Hardness is the most commonly used. When we talk about sensory tests, they have to be carried out according to regulations. There are specific standards to be followed to do these kinds of tests. And we need people. We need people to taste the foods. And these panelists, they can be trained for a certain type, to taste a certain type of product, like you have, for instance, for olive oils, for wines, or for cheeses. But they can also be semi-trained or non-trained. When they are non-trained, they mimic the behavior of the regular consumer. Of course, that when you use these techniques, they are much more time demanding. We need more time. It's more costing. So we have to balance between what we want to use, if it is instrumental methods or sensorial methods, or even a combination of both, because when we are, for instance, developing a new food product, we should use sensorial analysis and not only instrumental measurements. So, as I told you, for food development, I don't know where is the pointer. Okay, for product development, as I told you, we should not stick only to instrumental measurements, but when we are talking about, for instance, control quality on an industry, when we have a production line, in that case, we need to rely on fast measurement, and that comes through instrumental measurement. I'm showing you some case studies about bakery products. We have been working in our lab using texture measurements in different kind of bakery products. We have, for instance, one work in which we analyzed breads made with gluten-free flours. We prepared the breads, and then we analyzed the breads. I'm not going to show you the results. It would be tedious for you, but I'm showing how the measurements were made. And in this case, we did two types of textural measurements because they complement each other. For instance, we can use the textural profile analysis, which is a test that will allow the calculation of a high number of textural properties. Namely, we can obtain hardness, elasticity, resilience, and chewiness, and also adhesiveness. However, in this case, we didn't find adhesiveness. Otherwise, in this place, we would have a negative curve, and in this case, we didn't find it. We also did perforation test. In this case, we have a needle that goes through the bread, and in this kind of test, we will measure different properties. In this case, crust and crumb firmness, so on the outside and the inside, and also adhesiveness and stickiness inside of the bread. In another study, we evaluated this product, which is traditional from Portugal and specifically, more specifically from the region of Viseu. And we evaluated texture in two different versions of this sweet product. And again, we used the compression test with this flat probe to compress the product and also to perforate the product. And we also measured in different sides of the food, and then we would compare the results. And here in this, you can see that we find adhesiveness for this type of food. Now I'm going to give an overview of a work that we did, which analyzed how the textural properties of bakery products are generally analyzed in scientific works found in the literature. We did for this literature review on some scientific basis, and we used specific keywords to select the studies to include in this review. So we had some inclusion criteria. We only looked for research articles, not for review articles, which mentioned textural properties of bakery products, so not other types of products. And these, we wanted textural measurements regardless of being instrumental or sensorial evaluations. We also decided to include only publications after the year 2000. And from this, we did this research, this search on global databases, but we also did some specific search on this journal, which is typically devoted to analysis of texture. Following these criteria, we obtained eligibility of 133 articles. And we can see that there is a higher number of publications after 2020. And in 2022, we didn't have so many because our review was done in the middle of 2022. So that's why we still didn't have so many articles. Also, when we looked at the journals, the greatest number of publications appeared in the journal LWT, Food Science and Technology, and also in Journal of Textual Studies, but in this we specifically looked for the articles. Also in Journal of Cereal Science, because we are looking at bakery products, so which are made of cereals. We did an analysis of the keywords that appear in the 133 articles, and we obtained a total number of keywords, 432. But we selected those who appeared at least 2 times in 2 different articles. We excluded the keywords that were not linked to any other articles. In this case, we included in the analysis 64 keywords. The most frequent were texture, bread, bakery products, and rheology. And this analysis allowed us a construction of a puzzle with 10 clusters, with 174 links and a total strength of 190. We also did a similar analysis, but focused on authors and not on keywords. And from a total number of 607 authors, those appearing at least in 2 of the articles were only 29. With this, we formed 15 clusters with 19 links and a strength link of 36, so much weaker than for the keywords. The largest number of connected authors was 5, and the cluster centers were myself and my colleague in my lab, Dr. Correa. Then we characterized the studies, and we observed that there was a prevalence of studies focusing on bread, then cakes, cookies, and biscuits with lower number of studies. Other works focused on specific types of product, not only in cakes in general, but for instance, 18 studies were about muffins and 4 were about sponge cake. The products analyzed were also classified according if they have a harder crust, like for instance bread, or without a harder crust, like for instance biscuits, which we do not expect a difference in texture in the outside from the inside part. A flow analysis showed that from these studies, 62 of them measured textural properties using instrumental measurements, and 14 used sensory evaluation methods only. But then we found a high number of studies, 57, where both types of analyses were made, instrumental and sensorial. So we see a high number of these studies is about bread, you can see here, or cakes with 44. And also that we see that from the articles who report both types of measurements, from this 57, a high number of them represent biscuits and or cookies. When we see the number of studies according to the method, we see that for all types of products, the texture profile analysis is by far the most used technique to measure texture. As I told you, this measurement technique allows to quantify a high number of properties with one single measurement. Also, other types of compression tests, not specifically the texture profile analysis, are also very relevant. And other types of textural measurement tests are not so significant, at least for these types of fruits for bakery products. We also looked at the type of probes used, and the most commonly used probes are cylindrical probes. And in here we have different types. The flat 75 millimeter probe, which we use very frequently, but also these cylindrical probes with different diameters, 36 and 25 millimeters. And we also see that the three-point bending rig is also used very frequently in scientific studies when they evaluate texture of bakery products. Then we also looked at the test parameters, and we see that there is a very huge diversity of parameters used. For instance, for load cell, from very low weight to very high weight load cells, but the mode is the most frequency is 5. For the speed is 1 millimeter per second. Also trigger force, the most frequent is 0.05 newtons. The compression distance usually is 10 millimeters, and the number of replications, the most frequent is 3, but we found works with a number varying from 2 to more than 100, or here for almost 200, and it here more than 5. Just to tell you that when measuring properties through instrumental texture analysis, the properties most frequently analyzed are hardness, cohesiveness, shewiness, springiness, firmness, and resilience. When we talk about sensorial analysis of texture, there are also various types of sensorial methods that can be used. And we found that the sensory profiling is by far the most frequently used. The scales, we also found very different scales. Some scales with 100 points, some scales with 3 points, but the most frequently found is a 9-point hedonic scale. Regarding the type of panels used for sensorial evaluation of texture, we found that in 26 of the studies, they used trained panels. In 40 studies, they used untrained panels, and in 13, they used semi-trained panels. So there is also a high variability. As I told you before, to train a panel is very costly. The number of members in the sensorial panels is also very variable, from a minimum of 5 members to a maximum of 132 members. And most frequently, they use panels with 10 judges. The properties analyzed through sensorial texture, the most frequently found in the studies are hardness, cohesiveness, shewiness, and springiness. But in here, because people want to ask the participants what they feel, there are not standard names for the properties. And so in some studies, we find different names for the same type of textural property, like, for example, elasticity and springiness to mean the same, or hardness and firmness also to mean the same property. So I would just like to tell you that in this area of bakery products, breads, cakes, and cookies are among the most relevant bakery products that are in the whole food industry. And also for that reason, they are also very much studied. And we find a lot of articles studying the textural characteristics of these products. Then it's important to know that a combination of instrumental texture measurement with sensorial evaluation of the textural properties is a better way to know the effective texture of the products. But of course, that the utilization of both techniques is not justified in some kinds of applications, particularly in industry for quality control. Among the instrumental tests, the compression tests are the most used, and in particular, the textural profile analysis, because it is very simple to perform and allows the quantification of high number of properties. And regarding the sensory tests, most of them are descriptive, and they are performed by untrained panels, and they use a very highly variable number of panelists. So let me thank you for your attention, thank my research center and my institution for support.
Thank you, Professor Raquel Binet, for your interesting talk and results and detailed information also. Now, I ask the audience if there are any questions.
Thank you very much for your presentation. I'm Bojana Balanč. I'm coming from University of Belgrade, from Serbia. And I have one question, and I would be glad if I can speak with you later, a little bit longer. But for now, just a question about testing. Do you think that test which mimicates the chewing is important for as a texture analyze for food products? You know, in cycles, like compression in cycles.
Yes, it is very important. And as we see here, the texture profile analysis is the most used type of test used. And the texture profile analysis, if you see the curve that is produced by the instrument, is a sequence of 2 peaks. And this sequence of 2 peaks means that it is intended to mimic the chewing inside the mouth, because we chew the food once, and then we release, and then we chew the food again. And this is why this type of test was made in this way. We have a compression, and then we have a release of the force, and then we have a second compression. And it is really very important, because all measurements, all instrumental measurements of texture, they intend to mimic what we feel in the mouth when we consume the foods. How hard they feel, if they stick to the teeth, and if they disaggregate. For instance, this is given by the property cohesiveness. All this that we feel in the mouth was intended when designing the instrumental measurements of texture. So it's really very important. Thank you for your question.
Any questions? So I suppose we can finish because you have a delay. So thank you very much for your talk. No, everything was delayed. Thank you for you.
So we have a small modification in the program, because now we don't have Branko Bugarski, but we'll have Murat Kaya. Okay, can you
Professor Dr. Murat Kaya received his Bachelor of Science degree from Karadeniz Technical University in 2003. He completed his master's degree and PhD at Ankara University, Department of Biology. During his PhD studies, he studied at Royal Belgian Institute of Natural Sciences for 1 year and also studied at London Imperial College in the United Kingdom under the lifelong learning program for 1 year. He did a postdoc at University of California, Merced for 1 year. He was awarded as a Young Scientist of the Year 2018 in Turkey by Bilim Karamanlari Derengya. I hope I'm saying this right. He worked as a visiting professor at Department of Chemistry at Cambridge University between 2021 and 2023 and funded by Royal Society UK. Dr. Kaya has a permanent position at Akasara University since 2009. Currently, he's working as a professor at Chemical and Environmental Engineering Department, University of the Basque Country, Spain, since February 2023. He has more than 130 published papers and 1 approved and 4 applied patents. And also he has a product on the market named as Giant Microporous Silica, GMS. According to Google Scholar, his studies have been cited more than 5,711 times, and his age index is 45. So let's greet Professor Kaya with a warm applause.
Thank you. Again, you have 30 minutes.
Okay,
It
that's-
will be possible if.
I will.
Okay, thank you. So,
Hello, everyone. I have little voice problem, but I will do my best for the presentation. So currently, I have a permanent position in Turkey, in Ankara University, but I am moving a lot. I am working in University of Basque Country, Spain. I have 2 years contract. Maybe I can extend or I will decide later. So I'm a biologist. I am looking at material science from biological perspective. So this is the insect. And I'm looking at this insect. It has a very nice eyes. How can I use this eyes in the biotechnology? So I extracted the corneal lens in 3-dimensional shape, and then I produced nanofibers. Then I loaded drugs in between nanofibers, and it is a drug carrier anymore. So this is a just summary, and we published this one in the journal. This is another bio-waste in nature. This is the crustacean shells, like shrimp, crab, or any other animals. We are putting some plant extracts and we are producing bioplastics, then making some characterization, antimicrobial and mechanical and all the necessary experiments we are doing. And this is the kiwi fruit, but this kiwi is not the same we know. This is a Lithuanian kiwi fruit. It has no shelf life. So we tried to extend the shelf life in 2 weeks. We had little progress. So we are producing chitosan and making coating. And also I like nature. I like insect. I am producing nanofibers from different kinds of insect. And these nanofibers are made of chitin. And here in this insect, normally this part is divided, but this insect, it is not divided. So I produced chitin and chitosan, keeping the original shape of the material. So my dream here, my aim here, to keep the shape and put any oily things like chocolate inside and eat this one. When we eat this one in the stomach, it's becoming hydrogel. And this hydrogel absorbs a lot of oil, 40 times its weight. If you eat 1 gram of this one, it absorbs 40 grams of oil and take the oil out without digestion. So it's good for healthy weight loss. I applied for patents. It took 4 years, but I got it at the end. So it's not on the market because I didn't do animal experiments. I will do that. I did all the in vitro, but not the in vivo test. This is the crab mushrooms, and we are making bioplastics. This is another, I like Lithuania because I know I have a lot of colleagues, and whatever I need, anything they are providing.
So this is the parasite insects. They collect it in tons. So this insect eats the pine trees. And then we produced hydrogel and make films and the characterizations. This is the algae. You mentioned it before, but this is a high with cellulose. This is the fibers. So this is a bio-waste in Turkey, tons of algae. If you don't collect this algae from the lake or from the river, it's becoming eutrophication. Eutrophication is the water problem, water pollution. So we collected this algae, we made cellulose nanofibers. This is the commercial cellulose nanofibers from cotton, but this one is from the algae. If we put this one into the concrete, we made flexible concrete. This is the commercial one. This is our one. As you see, I am the biologist, but I published paper in construction and building materials. This is the dream journal of civil engineers. But the publishing is not difficult. If you have some crazy ideas, this is the publish. I like plant pollens. So this is the plants. They have pollens like this. In this pollens, there are the toxic materials inside. I am taking out all the toxic materials and we have the capsules. The size are like 30 macrons and it's all homogeneous capsules I have. Then we put drugs or any ingredients inside. It's a caviar. And we checked its effect on colon cancer, or we can do anything with this one. So the plant pollens, I worked in California, tons of plant pollens after rain in spring. So you can think, how can we find in big amount? But it's possible in some part of the world. And this is another animal living in Turkey. And I produced chitin by keeping the original shape. I removed everything out and I keep the original shape. In nanoscale, it has very nice nanopores and nanofibers. And we made characterization and we use this one for wound healing material. And we succeed. And we are still continuing on this topic. And this is the important one for silica people. This is the this is the sponge. I got this sponge from University of Copenhagen from Denmark. And this is the size, this is my hand, and my hand is a scale bar. And in this animal, in the sponge, there are silica fibers and silica beads. Do you see the beads and the fibers? I separated both of them by using some chemicals. And they are very white. When I was getting SEM images, all the surfaces are like this, but only one of them, I face it like that. What is this? The surface is all like this, but this one is different. Then I decided to break it. When I break it, there is a hole inside. There is a hole inside, and there are the channels, as you see. The channels are not reaching out. It's closed. So this is the natural outer surface. So I use hydrogen fluoride to melt the silica. After melting the first layer, I saw the pores. And then I tried many concentrations and I made a standardization. Do you see it's a biosilica beads? There are many pores and the sizes are 200 nanometers. And here, if you look at, there is a hole inside. All the channels are opening the hole. And there are almost 3,500 pores opening the hole inside. We gave a name like giant macroporous silica is negatively charged. And it absorbs the cationic dyes. It's very white. It reflects the light. Like 80% it reflects the light. It's another application we can do. So when I read the biosilica, there is a professor in Germany, Aldo Boccacini. I contacted him
And he told, if it is bioactive, this is a super nice material. And I sent the samples to him. He put this biosilica into simulated body fluid, like blood. When it touches with blood, it produces hydroxyapatite, as you see. So this is not the normal silica. This is a bioactive silica. When it touches with body fluid, it produces hydroxyapatite. And then I tried osteoblast cells, and the cells love the material. Do you see they are attaching one bit to other one? All the surface of the material covered by cells. So in the main component of the bone, one is hydroxyapatite, the other one is osteoblast cells. So both of them are growing one. So this is the material for bone tissue engineering. And also you can load any drugs or anything to accelerate the healing process of the bone. Then this is the summary. We extracted the material, we tried hydrogen fluoride, and we produced porous biosilica, and they are the hydroxyapatite formation, and they are the osteoblast cells growing on the surface. So we applied for patents maybe 3 or 4 years ago, still waiting, and published in Chemical Engineering Journal. The impact is like 16, and the material is on the market for laboratory experiments now, and we are selling 1 gram for $100, much higher than the gold, because it's going for bone tissue engineering. But this material, this sponge, is not very common. It's common, but it's in the ocean. It's on the bottom of the ocean. The fishermen, they are collecting them, and we are getting from them, and we are making production. But if we make a good organization, we can get in tons. So this is the material. There are the pores. We made only one paper. If you have any idea, please tell me, we can publish another papers. Especially, I'm wondering, can we use this material as a catalyst? We can modify it. We have all the properties in our published paper. And I don't know if there are any catalyst people. I cannot see. But if, anyway, so one day I was sitting in my office, it was Wednesday. I got an email from China. We want to come China. We need you. While we have tons of bio waste of cocoons, how we can convert this one into the technology. And it was a Wednesday, and on Thursday, I like the slide. So they showed me this material. This is the bio waste in China. This is a parasite. They are collecting these parasites and burning in full part of the China because it is damaged. It's a parasite for rice. So it's very economical things in China. I got this one from China. I stayed there for 1 week. And there are 2 kinds of protein. One is silk protein, fibroin protein, and the other one is the sericin protein. This is our material. This is commercial cocoon material. We did all the characterizations, and in vitro studies, the cells can grow on our material, but not on the commercial one. Because of the amino acid design, we determined it is amino acid structure. And then we tried mouse model studies. We paid a lot, especially for after this study, I got a lot of funds from China. So when you publish, they are paying me a lot. This is great. For 2 years, I didn't apply any project because I hadn't enough money after publishing this paper. So we put this mesh, surgical mesh, into the mouse in 2 different parts. As you see, the mouse accepts our mesh, surgical mesh, as it is own tissue. There is no scar formation. If there is a wound or something during the healing process, the body makes scar, and there is a mark, there is a sign on the skin. But here, there is no sign. And then we can see the formation of the veins everywhere. And then this is a graphical abstract. And we published this one in ACS Sustainable Chemistry and something else. And we applied for patent. I'm waiting the result. So it can be used as a surgical mesh in the human body, like hernia or any other operation, or in the brain operation. So the other one, what I am doing, one of my PhD student is working. This is the frog. Frog has a jelly, and these black dots are the embryos, but embryo is covered by jelly. And this is the polluted water. There are virus, bacteria, and everything. All the microorganisms are there, but this jelly protects the embryo in this polluted water. And also it feeds the embryo. So my question, when can I use this one? And then if we took out the embryo from the jelly, this is the hydrogel. We are working with a professor from Cambridge University. He is working on hydrogel. It absorbs 99.5% water. It's a pure hydrogen. And then we made a graphical abstract. This is the frog. And if we get the embryos, we have hydrogels. And if we try this one, we tried many cancers, many things, but it works for this one. This is a melanoma cell. This is a skin cancer. And if we use this one against skin cancer, it has anti-proliferative effect, and it has a proliferative effect on the normal cells. So it kills the cancer and feeds the normal cells. This is really interesting. Also, we applied for this one for patent, and let's see what will happen. And I did this study in Cambridge University for 1 year. I'm wondering, this is the animals, different kinds of animals. This is arthropods and this is the bryozoa. Normally, all the people, they know the chitin is designed in the bowligand architecture, this twisting form. But in this animal, we discovered that chitin is in the sea spider structure. And then we produced chitin and then made chitin nanocrystals. Then we made film, and we are making some helipodial design from this animal. And this is the most important part. This is the colorful film we are producing, but there is no pigment. This is the nano architecture. I cannot give all the details here, sorry, but we are, after this nanocrystals, we are designing nanocrystals in 360 degree. And if this size is around 500 nanometer, we have red color. If it is 400, we have green color. If it is 300, we have blue color. If it is higher than 500 or less than 300, there is no color. This is strange. So where we can use this one, we can use this one for colorful packaging. This is all pigments. They're all purple. So instead of this one, we want to use this kind of structural color. It's edible. This is the figure. And you can see, and we are designing on the left-handed leaves. So it's turning on the left side. And can you start this movie? Okay. So it has no color. When it is dry, we have another formation. But when I add little water, it's becoming color. So can we use, there are some food scientists here, can we use this one as a pencil? If we add little water, little humidity, it will be red. Little humidity, it will be like green, and if it is wet, it will be blue. So 3 colors to show in the package. Maybe if you have an idea, it's very cheap. So I like working with different people. I hosted many people from many different countries. I created my own lab in Turkey and I managed it for 10 years. And then I decided to improve myself and visit different places. And I gave lectures in different countries, China and Pakistan and another China, I have published papers more than 200 different people worldwide from many different countries, maybe almost all of the world, but not from Serbia. So this is a good reason why I'm here now. And for example, this is the Janel Levity we are working together now. And these guys are from Lithuania, and some from Netherlands, and Egypt, and Germany, and USA, and Italy, Riga from Latvia. And during my master's and PhD, I was there in Latvia. So I worked with many people. This is my former supervisor in Turkey, and this is my former supervisor in Belgium. And this guy, he was an Imperial College, but he's in Cambridge now. He was my former supervisor in Imperial College. And these three guys, they were my co-supervisors. They were in UK, and Elizabeth, she's in France now, but they were in UK. And this is the guy we worked together for some time. And I did postdoc with him in America. He's still active working there. And in Cambridge, I joined Sylvia's group, and she's a director in Max Planck, and also she's a now. And thank you very much for listening.
Okay, thank you very much for your interesting lecture, Professor Kaya. Is there any question for Professor? Yes, please.
It's me again. Thank you for this nice presentation, interesting and very dynamic. And I'm coming from Belgrade, from Serbia. And my name is Bojana, and I have just two questions for you. One is regarding the thing that you are working with material from nature. So when we are working with plant material, we sometimes have a problem in repeatedness of the results. And your expertise is with animals, I can say, or insects. So what about your experience with the repeatedness of experience in that case?
You mean, I think, the standardization, the method, you know?
Yes,
Yeah,
and
it is not easy for us as well. I'm just giving the graphical abstract, but behind this graphical abstracts, we have many things, you know? So for making a standardization for any method, it's not easy. So we are trying all the possibilities. Now in this lab, we have everything, all the filtration and anything. And we are trying all the possibilities, all the extraction methods, and we are making a standard. Especially these guys, they are all working on lignin and cellulose. This is my group in Turkey. It was from 3-4 years ago, but I'm just joined this group, and they are working plant materials. As I see from their works, they are trying everything from different concentration and autoclave, microwave for extraction. So we have the same problems like you.
Okay, thank you. It's
Yeah,
easier now for me. And the other thing is, a few weeks ago, I heard that that jelly from eggs of frogs.
Yeah.
It is acidic, sour. Do you have any idea about that? Why it is like that?
Acidic?
Yeah, it's sour. They
Okay.
said on, I think it was National Geographic, and they said it is sour to keep eggs from enemies in nature or something like that.
Yeah. There are more than 10,000 frog species in the world. All the frogs, they have their own egg jelly. So this frog we are working with is edible. Okay. So the jelly, it has no acidic thing. It has a lot of protein and some carbohydrates. So we characterize all the proteins. There is one protein, it is affecting on cancer, and we check all the excelligent gene experiments, and we have decided 100% which material affects the cancer. So there is no toxicity. We tried it for mouse, and we tried it for fibroblast cells, anything else. But for other frogs, you are right.
You're right. Some of them are toxic, some of them they have acidic. Every crop they have their own genetic.
Thank you very much. You're very kind.
Thank you very much for the answer and question. Is there any other question?
Can I, another, okay. After I do mine.
Okay.
Yeah, just a curiosity. You said you submit many patents and you are waiting for them, but at the same time you publish about it. Doesn't that prevent you from getting the patent?
You know, when you publish paper, in a year you have to apply for patent. You can publish first, but in a year you have to submit your patent. If you don't submit in a year after publishing paper, you cannot get it. But what we are doing, we are submitting patent and the paper at the same time, General. But patent takes more than 4 years. This is the problem.
Thank you.
Yeah. That was
And don't have problem with your mix in the different areas, because I am a PhD in the material engineer and I work with beef products, some plant products. So it's usual, I think. I have a question. Your work, I think, is related to the biomimetic, because you look for the natural and you try to do something useful. Okay. And usually you made all the principle of the biomimetic to do your work, or no?
when I go to nature, I'm looking at the nature differently, because during my master's and PhD, I studied like animal diversity, evolutionary biology, and DNA barcoding. So when I looked at the animals, I know it is taxonomy, I know it is distribution, I know it is body very well. So I'm thinking, how can I convert? For example, there is a insect in Turkey. The insect is giving the egg into the soil, just 1 centimeter. The mother is dying, passing away, but these eggs are in the soil. During the winter, the temperature is like -30, -35 in the mountain, but this tiny eggshell protect the embryo against frozen. We checked, some things are comes from the liquid, but the shell, just 25 micron, it makes maybe 7 degrees insulation. Everything is nature. We should look at nature and just mimic it. This is very clear. This is very clear. But I need to go nature, you know, I don't need to be in the office or in the lab. Sometimes I need to go nature.
Thank you very much.
Thank you.
And next, we have the sponsor presentation, but we move on from the, okay. Thank you very much to everyone and for your questions also.
Ladies and gentlemen, with this, we finish the second round of today's talks. I would like to thank our distinguished speakers and moderators for their contribution to EEM 2023. We will now have a brief section dedicated to sponsor presentation. I invite you to watch a short video presentation on Elixir Zorka, Shabat, Serbia. But before that, we will hear a short introduction. Elixir Zorka, Shabat, Serbia is a regional leader in the production of complex mineral fertilizers. Elixir Zorka produces various formulations of complex mineral fertilizers of the highest quality, with a high concentration of nutrients, uniform granulation, and high water solubility in the soil. Elixir Zorka products are designed to improve plant nutrition, increase application efficiency, and profit in production without harmful effects on the environment. Elixir Zorka is one of 12 company members of Elixir Group business system that is continuously developing in the field of chemical industry and agribusiness through numerous projects dedicated to sustainable development, application of the circular economy model, and improvement of resource efficiency. For more than 3 decades, Elixir Group has been investing in the application of cutting-edge technologies, innovative and sustainable solutions in all spheres of business. Significant investments in the previous 10 years were aimed at the development of the chemical industry, which in Serbia has a tradition of over 80 years. With more than 1,900 employees, Elixir Zorka develops partnerships for benefit through cooperation and support for sustainable community development. Now let's watch the video.
The Elixir Group is the leading producer of phosphoric acid in the region and the largest producer of complex mineral fertilizers in the Balkans. The business system consists of 7 companies with more than 1,600 employees. All Elixir Group companies are administratively and logistically networked and are located on the banks of the Danube and Sava rivers, through which waterways link them to the entire world. The business system is developed through the activities of 3 divisions: Chemical Division, Eco-Energy Division, and Industrial and Chemical Park Prahovo. The Chemical Division is the driving force of the business system. The main products of this division are phosphoric acid, mineral fertilizers, and aluminium trifluoride. The Elixir Group effectively meets the challenges of modern agriculture and agribusiness in conformity with international standards. Elixir Zorka and Elixir Prahovo products are sold on domestic and foreign markets through the sales and distribution network of Elixir Agra, which provides its clients with all the necessary agronomic and logistical support.
The Elixir Group's presence on the world market, following global trends and creating new generations of products, strengthens the position and competitiveness of the group as a stable partner for large consumers of mineral fertilizers. The global presence provides us with business sustainability, brand stability, and risk management.
Further development of the Chemical Division is aimed at investing in new technologies for the purification of phosphoric acid and production of chemicals from that base, expansion of the range of mineral fertilizers, and comprehensive improvement of resource efficiency. Recognizing the importance of the circular economy for environmental protection and the application of innovative technologies, the Elixir Group is launching a series of projects implementing modern and sustainable solutions as the spine for development of the Eco-Energy Division.
The future is in the circular economy. This is a powerful pairing of waste management and environmental protection with technology and economics. On the one hand, this means maximizing circularity in the production process and product life cycle, while at the same time establishing circular synergy with other industries and various technical processes. On the other hand, since the chemical industry is a major consumer of energy, implementing the waste-to-energy concept enables the reuse of waste to obtain energy or alternative energy sources. In other words, the complete replacement of fossil fuels.
This enables tens of thousands of tons of industrial and non-recyclable waste generated in Serbia to be processed according to 5R waste management principles in conformity with umbrella national and European standards, directives, and objectives. Waste-to-energy projects support the strategically important goal of decarbonizing production in the Chemical Division. By 2025, the Elixir Group will reduce the carbon footprint of its products by 2/3 and will achieve full carbon neutrality by 2030. By developing the production capacity and industrial infrastructure of the Prahovo complex, the conditions were created for the formation of a new division dedicated to the development of the Prahovo Industrial Chemical Park. The advantageous strategic location of Prahovo on the banks of the Danube, where the borders of Serbia, Romania, and Bulgaria meet, means it is an ideal site for development of Serbia's first industrial and chemical park.
Industrial Chem Park Prahovo is our most significant development investment and is aimed at partnering with the world's largest companies in the chemical industry. Its ideal location on the Danube, the existing infrastructure, energy efficient and sustainable production, together with a wide range of services at the best prices, will make Prahovo a highly competitive alternative to many European chemical parks.
Elixir Craft's expert team is designing and implementing integrated technical solutions for new infrastructure and superstructure capacity. Elixir Craft, as the park operator, provides efficient support services for the existing production processes of the chemical division, as well as new investments within the industrial chem park Prahovo. There is significant investment in development of the Prahovo International Port on the Danube as the logistics hub of the entire complex. Development includes increasing the transshipment capacity of the port and new storage facilities, as well as the construction of multimodal terminals for transshipment of all types of cargo from river vessels, railway trains, and cargo trucks.
As the world's largest producer of feed phosphates, the Rouillé Group, including its member Phosphea, had the opportunity to be the first in Europe to invest in Prahovo and take advantage of the many benefits offered by this exceptional location. This investment was only possible thanks to the support of the Elixir Group, our reliable partner since 2017. I am strongly convinced that the opening of the industrial chemical park in Prahovo will attract many other significant investors.
Industrial Chem Park Prahovo is becoming the center of new projects and investment cycles important for the development of the region of Eastern Serbia and the economy of the entire country. The development of local communities, which is an imperative for the Elixir Group, is supported through the activities of the Elixir Foundation, as well as through investments in education, talent development, and improving the quality of life. This is the goal of the Elixir Garden Project, a modern 5.5-hectare complex, which, as well as residential and commercial space, offers many sports and cultural facilities for active family life. The Elixir Foundation is dedicated to the conservation of natural resources and recycling, culture and education, and the improvement of health and social protection, as well as supporting many other projects of social importance. The Elixir Group has a clear vision for further development of industrial production processes and a distribution network with a wide range of new producers, customers, consumers, and innovative business models are creating an asset for the benefit of the community and a legacy for future generations.
Good evening, dear colleague. On behalf of scientific committee, we have a great honor, but also some responsibility to be a member of the commission for the reviewing and evaluation of the posters. And before we start in this official part, do we have some question for presenting author for e-posters? Because you have opportunity to have a discussion with on-site poster, but for this e-poster we haven't. So if someone have some question, please. No, we haven't. Okay, thank you. This is cool. Okay. We have, as I said, a great opportunity actually to hear great ideas for our colleague who present their posters, and to learn something new, and to with great and extraordinary achieve the results presented by our colleague on with these posters, and with especially pleasant for the commission was the presentation of our young colleague who also present their great ideas and great results of their posters. And this is official report, and the number of poster submission which presented in person was 13, and for e-posters for section chemistry was 21 e-posters. Section environmental include 19, section materials include 15 posters, and other section include 5 e-posters, which is now is presenting. So after detailed analysis of poster presentation, the committee was concluded that the poster label 0.02 presenting the paper titled High Molecular Weight Phytosan for Flocculation Bacillus from Fermentation Broth, author by Selena Mitrovic, is a winning poster. But it certainly doesn't mean that other poster is with lower quality for sure. But you know, this is the proposition that it could be only one winning poster. So we will be so happy that we can award all the presenting author, but it is not possible. So again, we would like to congratulate to our colleague Selena for the best poster, and first author of the winning poster will be rewarded with a free registration fee for the next conference, EEM 2025. So again, congratulations. Yeah. So this is the end of this official part, and you can bring your poster from the hall, and we will continue with. So please, I would like to invite the member of scientific committee to stay here. We will continue with our obligations. Thank you all.
Okay, good afternoon.
On behalf of the scientific committee, I will just read some statistic data regarding the poster session. The poster presentation committees on the sessions A and B have reviewed the submissions in the form of paper posters and e-posters on 21st of March and 22nd of March 2023. And the following conclusions were made. The total number of poster submissions which presented in person was 44, poster session A 31 and poster session B 13, out of total of 177 submissions. When it comes to the number of e-posters posted on our website, the total number of poster submission which presented online was 160 out of total of 177. And regarding the topics, engineering and technology 100, chemistry 21, environment 19, materials 15, and other areas 5. Also, the poster presentation committee rewarded 2 posters. One is in the topic of engineering of the first author Nevena Ilic, and the other one is from the topic chemistry. It is rewarded today from colleague Selena Dmitrovic. Those are the winning posters, and they will have free registration fee for our next conference that will be held in 2025. So now I open discussion, and you can maybe the members of the scientific committee can make some comments or suggestions regarding the poster sessions, the quality of the papers, and yeah, anything other. Yeah, maybe some suggestions.
As usual, you know, you make really great and high level of standards. So congratulations to all of you, and especially for Dean and your team, and for all of you. So you really great job.
Thank you.
Thank you very much. I really like this. And young people, young scientists are not motivated if they don't feel that they are supported by the older colleagues. So it was very refreshing to see so many young scientists in this conference, within this event, which is not so young anymore. This is a 14 years old tradition, and it takes a lot of time and efforts to build something like this. And the technical support was fantastic, and I must thank to the members of the technical support, because everything was smoothly organized and performed. So thank you very much.
Thank you.
Maybe next Congress to change the location, to going to the more south region. I don't know. Just suggestion. You know, we will make some kind of the vote between the you know, between these participants to suggest maybe next location. We are already 15 years here in Yakorina. Maybe to try some new location.
To change skiing with swimming,
yeah,
or something like that.
Yeah. Okay. Anything else? Okay.
Yeah, također, I would also like to thank you for inviting me and Victoria as well to this conference. It was very interesting experience to me to see actually what is happening in the region and to meet people and to see that there is a lot of things actually going on in Bosnia. And I think for Vicky was also interesting experience. Also the music and party yesterday, everything was, she really enjoyed it. We both enjoyed it. And yeah, I mean, only one thing, maybe this B2B session would be nice if it would really happen maybe next time more, you know, organized like really B2B, like people from industry talking with people with academia. This is something that is, I think, very useful for academia people to get new projects and also for our industry to actually that something gets out from the lab into a real application.
Yeah, thank you. And this year we are just started with the B2B to offering to the participants, and we already had a number of the B2B what happened, but the idea is that people on the platform get some contact and arrange the meeting. We already had a couple of the companies with the researchers that already done B2B, not here in this room, but here in the hotel also. So maybe your experience in the next B2B, especially from the industry, to suggest some new approach to get in the contact with the academia to arrange some kind of the meeting. You know, we have to in the agenda to give some time when to be happen B2B. But while we are here, all 4 days is B2B.
Sure. Socializing is a big part. But I was thinking maybe could be nice that is, for example, the last day. So then people already seen all the presentation from industry and know actually with whom they want to talk. Like if they know in advance, they can during the conference figure out actually if something can be of their interest. Just a suggestion.
Okay.
Yeah, but I know that there are a lot of spontaneous B2B anyway happening.
Yeah. We generally like that it will be spontaneous as much as possible.
Yeah.
You know, any forced situation is. It's my opinion.
Anyhow, yeah, just a suggestion.
Okay. Thank you. Okay, there is nothing else. That's it. Is it okay that we have to vote something?
No.
to write?
No. It's just like a short discussion with your comments, your compliments, your critics, and I think that if there isn't anyone from the audience to have something to say, we can close this session and also today conference day. So we have one session of lessons for tomorrow, and then we'll be closing of the conference in general. Okay, thank you.
Thank you so much.